Yeah, and that's a new feature of
Yeah.
Zoom where you have to authorize the recording.
Okay. I
So, all
hadn't
right,
seen that before.
June 8th, 2021. Welcome, Dr. Mike Ellis from the University of Central Arkansas, and we're going to talk about the Pandas library and some other data analysis stuff with Python. Take it away, Mike.
Okay. Well, hello, everybody. I am going to talk about pandas more than some of the other stuff, and we're going to do a lot of typing along. I will try to monitor the chat as much as I can, but lots of times I miss stuff. So I really don't have a problem with you unmuting and saying, "Hey, hold on a second," if we get put off a little bit. If you've got, well, I guess we've established everybody has the files and everything. So I've got. Well, there's technically 5 notebooks in there. I'm just counting them as 4 because 1A is just kind of a summary. I think we're probably going to spend more time on the first one than the others, but we'll go over a little more of the nuts and bolts there, and then we'll hit some of the other stuff, and then all the data files and everything. I've got stuff split between 2 screens here. So, and I may need to, as I start to share, I may need to shift my screens around here. Let's see. Yeah, heck, it's been a whole month since I've had to do a Zoom class. So now it's like I need to be trained all over again. Let's see. All right, I'm gonna leave it over here on the side, so I won't be looking straight at you. But like I said, holler if we run into any kind of issues. I don't work, this is the default theme for the notebook now. I don't work in that anymore. I use a dark theme, but I figured you'd all be in this, so we're going to work it. If we've got some time at the end, I'll show you some of the stuff about the themes and everything. That was one of those deals where I kept having students in a dark screen all the time, and finally started looking into it. And once I started using it, it's like, wow, it was actually easier on my eyes. But we'll keep it like this to start out. So you've had some introduction to, oh yeah. Also, I understand that you've used some of the folder structure that I typically use. I did not use that folder structure here, but if you moved your data into a data subfolder and your notebooks into a notebooks, then you can change the paths as you need. And if we need to, I'll mention that when we get there. But I just kept everything in the same folder just for the sake of getting through things efficiently at this point, but I'll be happy to talk about any of those other variations. One of the things I also want to talk about as we get started is that as of July 1st, you'll see there at the first part, our department, the department name is changing. We've been working on this for a long time, but because we were management information systems right now, and what we do is so much bigger than that now. So we have changed to this computer information systems and analytics. So we'll be the CISA department. Our classes are still going to be MIS classes until fall of next year. So it's going to take a while to get all that straightened out. But anyway, if you are looking for me or any of my colleagues here, it'll be in the CISA department starting July 1st. So we mentioned pandas, and a lot of this is taken from classes that I'm doing where I've already been working with students up to this point on a lot of the basics of both Python and the Jupyter Notebook. But Pandas is like the library for doing data analysis. It's got a lot of tools that make things easier, and we're going to explore some of those tools. You probably have, well, again, I don't know all the details of what you've done, but you may have seen some of the benefits of using libraries. If you haven't, then you will today. But it's just like with R, if you're familiar with it, I mentioned that earlier, that if you need some functionality that you don't have, there's probably a library out there that will do it, and you can load that in and use that functionality.
Yeah, Mike, that's probably worth 20 seconds to describe where we are so far. We've gone through, I used your notebooks, and we've gone through the straight line code and the use of functions and methods and different data types up through lists and tuples, not including dictionaries. Um, a little bit of work on functions, on writing your own function.
Okay.
Some exercises on, if then else and looping and whatnot. So basic structure of the language, but not a whole lot of work. I mean, they know what a library is, and they've had a few code samples where there were import statements, but not a whole lot of use of them. And all I've been, and no experience with pandas really, other than hearing me talk about it and promising, like you said, it's the library. So that's where we are as a class, is
Okay.
basic Python, but not really any analysis.
Okay.
Yeah.
Well, we're going to use a couple of libraries today, and so you'll get some experience with how they work, and they essentially all work the same way, at least on the high level. So I have a little bit here about why you use a library. Like I said, you have all this code out there that you can access and you can use, and I hate the cliche, don't reinvent the wheel, but this is a good example of it. If somebody's already written code that works and is reliable, then why would you want to rewrite that code? I mean, maybe you would for fun, but just use the one that's already there. Pandas has a lot of stuff built into it. Lots of different parsers for reading data files and putting things in the right format. And that's actually both good and bad. And that's where this minimally sufficient pandas idea comes in. This was something I read a couple of years ago that this author had proposed. And the idea is just that there's lots of stuff in pandas. With most of the things that you do, there's a couple of ways to do it. So why not focus on the way that works the easiest or most intuitive, and then the way that works all the time? A lot of it, if there's a couple different ways to do it, like there's different ways to access a column of data in a data frame, which we're going to talk about here in just a little bit. But one of them doesn't work all the time. So why would you even bother with that? So we're not going to. You might see it in some code examples, but we're going to use the version that works all the time. And that's what I try to do, is to focus on some methods that work all the time. If you get out there and you've been working with pandas for a long time and you've got some reasons to do some other ways, then go for it. But I think especially from the beginner's standpoint, that sticking to something like this is a good idea. And that's in my classes. I make the students stick to this. It's like, don't go online and start searching for stuff and do it a different way, because that's not going to work every time. So stick with what we're doing. You guys are obviously free to do what you want, but that's the whole reason behind it, is let's use this subset that's going to work all the time. There's a link here to the original article that I read and thought that was a pretty good idea. So you're welcome to go check that out. So the first thing that we're going to do, and actually one of the things that Pandas does really well is read data in so that we can do some more work on it. So the first thing we have to do is import it. We use that import keyword, which I guess you are familiar with. We also, in a lot of cases with libraries, we put an alias on them that makes it a little bit easier. One of the things that, when I've been working with students for a while, by the time we get here, they've already heard me hammer them about not using really short variable names and using self-documenting names and things like that. And then we get to the import statement for pandas and we change it to PD. And so it's like, hey, we're using this really short name to alias for it. Well, that's what's done. That's the standard. So that's what you'll see in examples. So that's what you should do. Anytime you look something up, you're going to see somebody imported as PD, import pandas as PD, and then we can use that moving forward to import data and do all of our other things. So pandas, actually, if I run that, I don't know if you're aware, if I do Control Shift or Control Enter, it'll run that cell, or you can choose Run up there. If I do Shift Enter, it'll run it and go to the next the next cell, if you do Alt Enter, I think it runs it and inputs or inserts another cell. So some shortcuts in Notebook that are handy. So we always, if we're going to do something with pandas, we always have to start with that that statement, and then we use a read statement. So we use that PD name that we just did. That says go into the pandas package, and then we use the dot notation to say what comes after it as part of that. And it is a built-in function called read CSV. And actually, I should have, when you get to read, let me see, there, I hit tab, it takes a second. You'll see all these different versions of read. So it does have read SQL and read pickle. You made it, pickle is something you can do in Python to save data. Feather is involved with R, Excel, and CSV. Clipboard. Clipboard, you can actually, I haven't messed with this, but you're supposed to be able to copy a table and then read from the clipboard, and Pandas will put it in a data frame. So I've got to try that sometime, but we use read CSV. And I'm going to talk to you throughout here and ever that about 95% of the time you should just use read CSV. You can add some arguments and things to change what you're reading a little bit, but stick with read CSV. It's a function, so it has the parentheses, and we put the argument in the function, and in there we put the path to the file. In this case, because I have my, let me make my screen size just a little bit bigger there on the text. Because I have the data files in the same folder, I just need to put the name of the file, and this one is going to be Applewood with the A capitalized underscore 2011.csv. Don't forget the .csv. That's the thing I forget most often. If you've got it in a, if you're using the notebook and data subfolder, then you would put // data / Applewood 2011. Now the thing is that calls that function, but it doesn't do anything with it. We've got to have it stored someplace. So just like you would store something in any other variable or object, we need to have something on the left side of an equal sign, because the equals is the assignment operator. And I'm sure you've already talked about that. So whatever is on the right side of the assignment operator is going to be stored in the left. DF is just kind of a generic data frame name. Lots of times with this database, I'll call it cars or something, but you know, whatever works, we're just going to go with DF for now. So if I run that one, you'll see it runs very quickly because it's just reading a relatively small data set. So as I have here, right after it, is you've got a link to the Pandas reads CSV, and there's, like I said, there's lots of, in fact, let's just go ahead real quick, since it's easy to do when I'm sharing this whole window here. Look at all the different arguments that you can have, all the different parameters. You can have it, you can tell it, it says, or it defaults to having that the first row is a header. If you look at that data, it has names of the columns in the first row. That's the default. You can change that if you don't have it. You can, date parser, you can parse dates. We do that some when we're dealing with date stuff. We tell it which column is a date, so it'll take a look at those and treat them as dates. There's lots of different parameters here that you can change, and a lot of different discussion about that. So I highly recommend that stuff in that pydata.org as far as the general background of how to use some of these. So keep in mind, PD calls the Pandas library. That .read CSV says the read CSV is in there, and then we've got the name of the file. So the default CSV is comma separated value, right? It's not CVS. We always make mistakes like that. It's like, no, it's a comma separated file, not a drugstore. So, but it's easy to get those mixed up. But CSV file is kind of a default in a lot of these data operations. For a very good reason, it can be read by pretty much any software package that's out there. If you have an Excel spreadsheet, you have to have something that can understand and decode an Excel spreadsheet, data from an Excel spreadsheet. But CSV can be read by anything. I mean, you can open it up in Word. It'll open up in Excel real easily. So we try to use those CSV files. I do use a tab delimited file sometimes in classes, so you can change this delimiter parameter there. You can change it to a semicolon. So there's lots of other options that you can use in there. But CSV files are just text files. They just, if you open them up in a text editor, if you haven't ever done that, I recommend that you do it. Take a look, not in Excel, but in like Notepad, and you'll see they're just the values and a comma, value, comma, value, comma. And that's what it's doing, is it's looking in the first column is up to the first comma, and the second column's up to the second comma. So that's the default. When you read that, it stores the results in a data frame. Now, a data frame is the heart of what Pandas does. It's also at the heart of R, if you ever mess around with R at all. And a data frame is really just a table that's in memory, but it's got some special construction to it that we'll talk about in the rest of this notebook that make it actually pretty cool for working on data like this. One of the ways that we do that is that each row has an index. So we can go through and uniquely identify the row with that index. If we don't specify anything, like we didn't specify anything here, it's just going to be an integer that's assigned as the data is brought in. But we can actually assign indexes, and we'll talk about that again in a little bit. That data frame is an object in Pandas, and it has a lot of built-in methods. So it's kind of like we ask the data frame some built-in questions, and it returns stuff to us. So we'll see some of that too. I mean, we can ask it what the mean is, and you know, just all kinds of stuff, info and describe, and we'll go through all of that. Well, one of the things when we read the data into a data frame, one of the first things we want to do is take a look at it, see what it looks like, get an idea of what it is that we're going to be working on. So there are some very brief methods that are built into the data frame that we can call that will give us an idea of what's in there. We can look at the first or last few rows, find out what type of data is in there, how many rows, what the size is, some descriptive statistics, a lot of stuff. So we're going to do some of that here first. There are, like I said, a lot of them, but my favorites, I use the head method a lot. It shows by default the first 5 rows. Tail by default shows the last 5 rows. If we put a number in those parentheses, then it'll do that many rows. We can look at the column names with the dot columns. It's an attribute, so it doesn't get the parentheses. But I use head all the time, and then info and describe, these other two. And you'll see what they do. Describe gives us summary statistics. Info tells us what everything looks like. So let's take a look at like df head. And remember, df here is the name of our data frame. You'll see it a lot as a generic, but there's nothing special about it. We're just using that as a default. It's kind of like using X in algebra. It's just a default value. So if we do head, we see that it shows us what are in the first 5 rows, and it also gives us the column names, age, profit, location, vehicle type, and previous. And it also gives us the row indexes, 0 through 4. If we do, actually, let me, yeah, Alt Enter inserts another cell. So I'm going to, let's run describe, info, and then we'll do describe too. So you see info tells us it's a data frame. It tells us how many rows, 180 entries, that's how many rows. They're indexed from 0 to 179, so that's 180. 5 columns, and then it tells us the name of the columns, how many non-null values there are, and then the type of the value. So age is an integer, location is an object, Object is what we call strings in Pandas. And then, previous is an integer. So that looks like it's something that we would like. We'll talk in one of the later notebooks about changing data types and stuff, but that looks okay. It gives us a summary there of what data types are here, and then tells us how much memory we use up, which is not much because it's only 180 rows with 5 columns. The other one that gives us such a really good look at the data is describe. It gives us summary statistics of all the columns, except it's not all the columns, is it? It's only the numeric ones. It does not include those object columns. Although you can, I think you have to put you have to put it in quotes. You can include the option all, include all, and it'll tell you a little bit about those too. Now in this case, since they're just object fields right now, there's not a whole lot of value there, but actually the location at least should be a categorical variable, and we'll talk about that later. Another thing that you'll see here is this NaN. I don't know if you may not run into that, because NaN is a Pandas thing. What it stands for is not a number. It says there's nothing there, so it's a null value. If I remember right, the general Python value that's put in for a null is the word none. There's different values in different languages, different environments. So NaN is for Python, or for Pandas, and we'll talk about that a little bit more too in the missing values. But you see, of course, with the location, because it's just strings, there's not going to be a mean or a first quartile or anything like that. So lots of times with this, you don't need to use the include all. But if you've got a categorical variable, if that was set up as a category and not just a string, then you get a little bit more useful information on it. But anyway, we're going to play around with those data frames a little bit more. And unless somebody slows me down or stops me, I'm going to keep going. So it's one of the unfortunate things about these Zoom things, is that I can't really see what everybody is doing. So if there's any issues, let me know.
I don't have 5 and 6 paragraph numbers.
Oh,
we're good, right?
Yeah, I meant to turn that off. What this is?
That's an auto thing.
It's an extension. I would talk about extensions too, but this is the table of contents extension. And so you see, I can click on that, I get a table of contents, and so it has the 5 Pandas main data structures, and you can go between the different sections over here. But that is an add-on thing. I've got a couple others installed here too. I was planning on disconnecting that before I did this and forgot about it.
No, that's slick, Mike. I've been talking about how a Jupyter Notebook is a great way to document your research, as well as give the code in an interactive live format. So those are just good examples of why this is such a good. I mean, you could do a whole textbook like the the data science handbook is in a Jupyter Notebook. It's a textbook.
Yeah, there's a couple of books that I use that they say this started as a notebook.
Awesome.
And like here, I can go to this one is it makes the input go away. It hides the input. So if you're going to, let's say you're going to go talk to a the VP of sales, that person probably doesn't care about what code you write. They're probably more interested in the results. So you can make that hide that. I've never figured out much with that. This is one of the more useful ones that I've seen, although there's not much in memory. That's the variable inspector. Why is that not running? That brings up a little window that will show you what variables are in memory and what they are. So if you, again, I mentioned R because I'm working with R and some other stuff, and there's a lot of things that are parallel. In R, there is a window where you can see all that all the time, so it's really handy to have that available. Like I said, I don't know, at least DF ought to be showing up there. So I'm not sure why that, I was just using that the other day. But if I go back to my main, I've got this NB extensions, that's where it's managed. So all these others are extensions that you can add, and the ones that are checked are the ones that I have loaded up. And you'll see down here, table of contents too. That's what that is on there. Variable inspector is checked, but it's not wanting to work. So anyway, just a little side. So you shouldn't have that NB extensions tab on this screen either. It's actually a pretty easy addition. There's a bunch of stuff, and I've got some stuff somewhere in some notes about how to do that. But that's why that 5 and 6 are there, is the table of contents.
Cool.
So there's two main data structures in Pandas. The data frame, which we talked about in the series, and we're gonna talk about the series because data frames are made up of series. So the data frame, like I said, is a rectangular data set like a table. It has columns and rows. One of the interesting things about it is, just like an Excel spreadsheet, you can have text right next to integers, right next to floating point numbers, right next to other text, and it doesn't matter. If you have an array in most languages, it has to all be the same data. So it's a really handy data structure to handle stuff. But each column is a series, so the series has to have the same kind of data in it. So each column has the same data, and then you can have different columns. And you'll see it's handy the way it's built. The data frames are actually built from the columns, and it's how it keeps everything together. So we'll see some of that. So like I said, it's not really an array, but you'll see some things like array, and I believe you've talked about lists. So you'll see some things that make it look like they're the same thing, but they're not. If we run these two cells, then you'll see the difference. The list is here on my the 8th cell that I've run, but we turn it into a series with this pd.series function. Now, we don't create series this way very often, so don't get too hung up on that. But if you need to do one from scratch, you can do it that way. So you'll see it's got the same values in the same order, but it has the index for the row out here. So we can actually call the dot values and dot index, and it will show us what's in there for both of those. But we can look at, just like with a list, we can look at the index number and get the value out using the square bracket notation, just like you did with a list. So if we want to get our get the value that's at index 1, we have a series called data, and we use the square brackets and the 1, and we get that value. And you see, because it's 0 based, 0, 1, 2, 3, so the 1 is 2.5. So we can access it the same way we do with the list. But it's not the same. It's not the same as a simple array for one big reason that really comes in handy for creating the data frames. And that is, the list has an implicitly defined index where it's always going to be 0, 1, 2, 3, 4, and on. In a series, it's an explicitly defined index. If you don't specify something, it will assign those 0, 1, 2, 3, but you can go in and assign index values. So it allows us to put anything that we want in there as the index. So here, let's run this, and we'll see we have those same values, but we add an index argument, and we have a list, these arguments in lists. We're going to see that a lot. We have these square brackets in here with the values. That's a list of values. So we have that both series and index, and it's going to match them in order. and then we print the values and the type, and then we print what is at data C, and it's 2.75 because we've got the values A, B, and C. So we can access that by using that explicitly named index, and we don't just look at it by the position in the list. So we can literally call it whatever we want. Even we go to the next cell, we can even give it number values that are out of order, because they're not really numbers there. They're numeric characters that are used to index the value that's there. That's a big deal. That's what allows us, the way a data frame, a little bit of a foreshadowing here, is the way the data frames are built is we have series that share indexes between them. And so we put them together and it keeps things lined up because each row has the same index. So even if we mess them up and do things, we keep those indexes the same, and everything stays together the way it's supposed to. So we can't do, I'm sure if you've worked with Excel spreadsheets before and that you've accidentally sorted and forgotten one column or changed something and then it messed up all your data. That's what keeps you from doing that when you're working in a Pandas data frame. I know I've done that before. Now there's a couple of functions called LOC and ILOC, and we're going to use them. And yes, they're a little confusing. It takes a little getting used to do them, but they work a little bit differently. LOC works with the actual index value. So like in this series I just did, the actual index value here would be 1492. And ILOC works with the integer position value. If it helps, think of the I as the integer position. So you can say a 2 and you'll get 1492 if you do it with ILOC. Again, yeah, it's a little confusing. Yeah, you'll get used to it. But I will also tell you that you're not going after specific values too often in your data. We're going to work with some data sets here that just have, a few dozen rows. If you're talking about data that has 10,000 rows or 100,000 rows, or I have students that work at Axiom that talk about working with data sets that have over 100 million rows. I mean, it's real hard to find one specific value. So we're going to use some things to find stuff based on conditions here in a little bit. But we can still use LOC and ILOC. Sometimes we might pull something out and we'll have an idea of where it is in that value. But it's just a matter of getting used to it. And I don't use it so much, so sometimes I have a little trouble with it. So if we want to use LOC to get the value at index 37, we saw up here in the series that we have an index of 37. So we can do that, and we use the square brackets again and say 37, and we don't hit enter in the middle of it. That doesn't help. And you see it gives us the value of 3, which is what we expected, or 3.0. It is a float. If we want to find the value at position 3, let's see what that would be. This would be position 0, 1, 2, 3. So we should get that same value. So if we say data.iloc and then we say 3, we get the value of 3.0. So it's the same value. We get it using 2 different methods of the data frame. You're usually better off using this LOC version because with the specifying the index specifically, it helps with that self-documentation where if somebody comes in and says, if you're looking at this code that somebody else wrote, my first question would be, why do we care about the value that's at index 3? What's special about it? So if you don't have any other documentation, it's hard to know. With LOC, we know, okay, so it has an index of 37, so that must mean something. I mentioned before, there's lots and lots of methods built into the data frame. So, just for fun, we're going to use some of them, but you can, or this is actually our series still. We have the mean. We can just call the mean method that's built into the series, and it will give us back the mean of the values that are in there. If it's a string series, it gives us an error, I believe. I don't remember, but you won't get a valid response. If you go back here, that's 2 5/8. If you go back to those values that were in there and do it, then yeah, because they're symmetrical, so 2 5/8 is in between. So yeah, that's right. I always like to check, especially when I'm using something I haven't used before, just check it and make sure I'm comfortable that it's doing the right calculation. There's also mode and median and square root and you know, you've got lots of other functions that are built in. If you go to, I think I had a link to the data frame stuff up top. If you go to data frame, you'll see there is just tons and tons of stuff there. Everybody's okay?
Chugging along.
Okay.
There was one thing I was going to get you to show and talk about briefly, Mike, and that's
Okay.
like in that last cell, that previous cell where we calculated the mean.
Yeah.
I was goofing around with a couple of other ones. Like if you do like data.mean, open paren, close paren, and then on the next line do data.median, open paren, close paren, all you see is the median.
Yeah.
And I've told these guys, I hate just typing the variable name because it overwrites the output or whatever. I always use a print statement.
Yeah.
So you want to, if I get knocked offline, it's because really good lightning storm coming through North Little Rock right now.
Okay.
So anyway, yeah, if you could talk about the way that just the variable name versus the variable name inside of a print statement works with Jupyter Notebook.
Right.
Just for a second.
Yeah, and this is a notebook thing. This is not a Python thing. When you're just displaying the value like we did there, it just overwrites whatever's in there. And you can see it has that out 16 there. If I highlight that whole line and then do an open parenthesis, it puts parentheses around it. It doesn't overwrite the whole thing like it does in Word and probably just about every other software package you're used to. So there's another thing that you get used to, but it's a nice little shortcut. And then I can put that inside a print, and it's going to treat that differently. Now, if I do the first one, if the last one isn't inside a print, it'll still display, but everything inside a print will maintain there. So I can also go, I can put them both inside print, and they'll both be there. I could also put them in the same print and just print them side by side. I could put in new line or whatever I need to do. But if you're going to print, most of the time I will either put them in print, or sometimes I don't feel like typing print over and over. I'll just put it in another cell and do it in the next cell and let it sit there. So whatever works for you is fine. But that's something that, yeah, it's another one of those little things with the notebook that you have to get used to.
Thank you.
So I mentioned that we're still going to use LOC and ILOC a little bit later, but we don't really use that a whole lot to find data. Most of the times we want to find particular values based on a condition. Like we're going to look at some exam scores. So we might be interested in all the scores that everybody that got a B or better, or maybe we just want to look at the C's. So we can look at writing a conditional statement in order to find the values of interest. It's just like SQL or structured query language, or SQL, depending on how you want to, SQL or SQL, how you say that. It's like writing a little query. There's also Excel formulas that can help you find stuff. I use count if all the time to look at it. If it's a B, then if the value is B, then count all those B's and give me the count of the B's back. And so there's lots of functions like that. So you've probably seen something like it. There is a general form. We give it the series name. In this case, we've saved it in data, and then the square brackets, and then we write the conditional statement in there. So we're going to use a little bit bigger set of data. And as we said, it reads it into a data frame. And again, if you have the subfolders, then use the /data/stats_exam3scores.csv. You can add that in there inside the quotes. It's going to save it in a data frame, and then we're going to extract that column. And so you'll see in my line 5, and actually there's something else I didn't mention, is if you don't have these row numbers here in the cells, you go to view and click toggle line numbers, and I'm going to toggle it, and it turns them off, and I'm going to turn it back on. So I find it very helpful, especially when if you're working by yourself, it's not as big of a deal, but if you're working with somebody, it's a lot easier to say, I have a problem in line 28, can you help me? Rather than saying, you see down there where I have the print, and then I do this, and then, so I usually have those on all the time. So we're going to talk a little bit more about pulling out one column, but you'll see we're going to read the data, store it in this data frame called exam scores, and then there's going to be a column in there called scores, and we're going to, in line 8, extract that and save it in a series called just scores. And then at the line 9 shows the type of scores, just to verify that that's what we did. And you'll see it is a series, capital S series. That's the name of the actual data structure in order to delineate it between other series that you might see. The series will have a capital S, the data frame will have a capital D, and I think a capital F too. But so it looks like we're probably where we want to be on that data. We can, in the next cell, print it and print describe to see what it looks like. So again, we've got the integer index numbers, because we didn't bother to assign anything, because it really doesn't matter in this case. And these are actual scores. This is from stats test 3 over a couple of semesters from 3 or 4 years ago. The exam was worth 150 points, and these are actual test scores from my students from that time period. And you'll see by default it prints 30 lines, and then it puts the ellipses, and then it prints 30 more lines, and then it gives you a little summary information. You can change that to there's settings, and I'll use some settings later where you can see a lot more rows if you need to. And then this is the describe output. So there's 381 values there, and you have the mean and the standard deviation and all the rest of that stuff. So we have an idea of what it looks like. So we're going to take a look, and let's get, out of 150 points, let's see how many got 145 or better. And there are some. You'll see the max is 150, and the third to the last value is 150, and I know there's some others in there. So let's take a look at the rows that have values of 145 or more. So the way we want to do that is we have that series scores, and remember that generic form that we were just talking about a minute ago. We have the name of the series, and then the square brackets, and in the square brackets we put the logical conditional statement that we want to check. And what we want to do is we want to find all the values in scores that are greater than or equal to 145. So I think where it gets a little confusing is that we've got scores on the outside, and then we have to have scores on the inside. But that's the conditional statement, is we're looking at everything that's in that scores series that's greater than or equal to 145. And you see, we have those, what is it, 7 values. It shows the index on the left, and then it shows the value on the right. So we have scores, we have 1, 2, 3, 4 145s, and 3 students made 150. So 7 out of 381. But it's kind of interesting if you look at what is going on there. If we just, I'm going to copy and paste that there, and then I'm going to put it inside a print statement. So let's look at just the conditional statement there. So you see what it does is it runs that and it returns a value. So it looks at the first value and it says, is this value 145 or greater. And it says, no, it's not. So it returns false. And it goes down, and you see 7. We saw the index of 7 before. It says true because that was, I think, 145. So it returns true. So it goes through that whole series. And you remember the third to the last one was also true. So it generates a Boolean series. The Boolean type is the logical type. And then it applies it to the database, and it says, it compares those series, and it says, let me find the ones where the value over here is true, and I'll return those values. So there's a lot going on there. And that's one of the things that I try to emphasize all the time with Pandas is lots of stuff is really easy, but I think it's important to understand and appreciate what's going on behind there because it's doing a lot of things for you. So if you look at here, it looks at each value and scores, and it creates that parallel series, and then it subsets based on all the ones that have a true value. So it's pretty slick, works really well. So let's take a look at another value here of doing this Boolean subsetting using a conditional. So let's look at all of the failing scores, so below 60%. So 60% is 90 because there's 150. So if we are going to get those, we'd have to have the name of the series, square brackets, and then the conditional statement, and that would be the values of scores where they're all less than 90. And we'll see there's a lot more values of that. A lot more students, exam 3 is hypothesis testing and something else in the stats class. So it's the grades aren't always the highest there. So we had a lot more that didn't do so well on the test that did at the very highest levels. But again, it pulls out everything that is less than 90.
Yeah. I want to ask, Mike, but if you want to defer to later in the presentation, that I understand. There's a concept that you described to me in class where Python or Pandas automatically loops through these series data types. You know, it'll automatically do, with one line of code, go through.
Vectorization? You're talking about vectorization?
Vectorization, that's it. Is that something you can explain during this presentation at the right time?
Yeah. Yeah, we'll do some of that a little bit later.
Because as an old Pascal programmer, that just blows my mind that one line of code automatically goes through, iterates through a list or something, you know.
And there's a little bit right after this.
Cool. All right.
About that. So if you were doing it, then and we'll talk more about the vectorized functions a little bit later.
What a segue! Look at that.
Yeah, good segue. So I guess I'll send you the $5 tip by Zelle or something for putting that in there. But if you were doing it in Pascal or C++ or Visual Basic or any of the other languages, and you wanted to go through and find all those values, you would have to write a loop. And since you guys have seen loops, you know what gets involved, and sometimes they can be little ones, sometimes huge ones. But you would do exactly what I was just talking about a minute ago, is you would look at each item and say, is this value less than 90? It is? Okay, let's return it. If it's not, let's go and do it again. And you would loop through all that. That's all built into the Pandas, the functionality that we're using here in Pandas. So in the data frame and the other stuff that's there. It's because of this idea that Don brought up of these things being vectorized. So a lot of the methods and functions will, in fact, there's the methods, you understand, it makes sense because they're built into the data frame and the series and those other data structures. But a lot of the functions that are separate, you pass it the name of a data frame, and it works over the whole data frame, and because it's built that way. So they're vectorized. They work on the whole data structure at once. You don't have to tell it work on the whole thing. That's just the way it works. So like Don said, you have a function name and a data frame, and it does all kinds of stuff and spits out a value for you. So I mentioned that we talk about the series because that is the building block of the data frame. And really the data frame is what you wind up using the most when you're working with data in Pandas. So I'm going to look at this, and I mentioned the aligned series objects where they share the same index, and you'll see some of that. You'll also see why it's so common. We can one of the things to get used to there too is that they'll talk about the row labels are the index values, and the column labels are the names of the columns. And we can pass some of those, and we're going to look at that here in a little bit. And we can do it when we're building it. Here again, I'd be really surprised if you use this method for building a data frame out in the world. We usually do it by reading the data in, and it's in a data frame, and then we work on it. But this is just to work with one that's just a little one that we can fiddle around with. So this actually uses a dictionary. You can tell it's a dictionary because it has curly braces at the beginning and then the end if you go far enough out here. A dictionary has what we call a key value pair. So the key here is name, and then the value is this list of names. And when we run it through, use this data frame function in Pandas, it reads that dictionary and it turns it into a data frame. And in this case, we're going to save it into one called Pythons. And all of that may not make any sense to you, and that's okay. But just be aware of it. Like I said, I'd be very surprised if you ever really needed to use this method out in the world, because we create our data frames when we read data most of the time. But this gives us a, you probably talked about that Python was named after Monty Python, and so there's a tradition of using Monty Python material in examples, and I do that in several places. So if something just looks weird and you don't know what it is, it's probably a Monty Python example. But here I've set it up with some different values. We have a name, office, and favorite are all going to be objects, and then age is an integer. So if we look at this and ask what part of this is the actual data, well, it's the name, office, age, and favorite, because 0, 1, 2, 3 are the row indexes, or the row names. We can use that. So we get that default. But we say those index values uniquely identify a row. So if we have something like a student ID number or social security number or something, or in this case, a name that uniquely identifies the row, why don't we use that as an index? So that's what we're going to do here. Is now there's this index option. And if we run that, you'll see now the data is actually just the office, age, and favorite columns, and the names are the indexes, the index values that identify the rows. So that's all that's really changed here. But that's something that's very useful when we're working with data frames. Just like any other set of data, if we have something that uniquely identifies a row, let's use that as the index. Lots of times it's an ID number. I've got, I think the data we're going to look at later, that's from an actual survey that we did. It has survey ID numbers. Well, that's what the whole point of them, right? Is it identifies each row, each person that responded. So we'll use that as the index because it's no good to us for any other reason. But now we can, we're going to do some subsetting of the data frame, like we did with the series, where we can get certain values out of there. So we can subset in a couple of different ways. One is by column, where we maybe have, we'll see in some of those bigger data sets where we have, maybe 40 columns, and we really only need 12. So we call that attribute reduction, because the columns are referred to as attributes of the data set. We're not getting into tidy data and all that here, but the idea being that that table should have data on just one entity, and if it's on something else, then you put it separately. So the attributes are all going to be on that one entity, and maybe we just need some of them. You'll see with some of the survey data that I'm going to look at, it was a survey that was done from people that live in Taiwan. There was a bunch of questions about computer use and cell phone use, and we're going to look at just the cell phone use. So we reduced the attributes to just those at some point and then pulled that out. If we do it by row, we call it slicing if we're just taking some rows out or looking for specific ones. If we're using some other way of doing it, like maybe a random number generator or something along those lines, we tend to call it sampling. And we can do both. So we can pick just these 12 rows for just these, or just these 12 columns for just these rows. So we can do them both at the same time. So probably the easiest thing to do is to just select a single column. And we did that a little bit earlier when we read that data into a data frame and then pulled one column out to be a series. So remember that the data frame is built from the columns, not the rows. Each column is a series of the same data type, all the same data in it, and the series all have the same indexes to keep them lined up in the data frame. So we can take a look at a couple of different columns and actually verify that that's the case. So let's take a look at the name of our data frame is Pythons, and let's take a look at the age column. Now it is case sensitive, so if you typed age with a lowercase a, in fact, let me just do that. First of all, it takes a while to run, right? And we get an error. Actually, here's a little tip. When you're looking at the errors, usually the first part of the error and the last part of the error message are the most useful parts. And here it's the last part, key error age. It's telling you, I can't find age. There's no key called age in there. That's because I didn't have it capitalized. So if we look at the right name, it shows that. And then let's look at Pythons, square brackets, quotes, capital L, no, favorite I wanted to do here, favorite. And you'll see we have the index values on the left in both of them, and they're the same. Michael, John, Graham, and Eric, Michael, John, Graham, and Eric. And so that's what keeps those matched up. It also tells us what kind of data we're dealing with on each of those. So if you want to, we did before, we just extracted, like here, we just extracted the favorite column, but we didn't do anything. We just displayed it by writing that there. But maybe we want to save it in a separate object. So let's extract the location column, save it in a separate object, and inspect the first 5 rows. That's actually the code that you do that. I'm gonna copy that. So which this kind of leads me to another thing. We've been, and I'm sure you guys were doing this earlier, but in a lot of my examples here, we're only running a couple of lines of code. Of course, you could have 1,000 lines of code in a code cell. It doesn't matter. So don't think you have to break everything up into its own cell. When we get into analysis, we'll find that there are some really convenient breaks that we can do in our data analysis. But here we're just kind of moving on to the next thing. I don't want to overwrite what we've already done. So there we've got now a new data frame called location_df. Let me see if I don't know why that's not working. My variable inspector extension.
Hey, Mike, we're coming up on an hour. Do you have a break point in your mind? Or?
Yeah, maybe after that little practice thing, and
Gotcha.
be just a few minutes.
Cool.
That'll work. So we have location_df now, and so we can take a look at what kind of data type it is, and that is a standalone function we just called type, and then put in the name of the variable that we want. And don't forget about the autocomplete. If we type in a few letters, I think we have to get to like 3 or 4, and then hit tab, then we'll either autocomplete like it did here for me, or we'll get a list of options to autocomplete. And it tells us that's a series, which is what we expect because it's a column out of our data frame. And we know the data frame is made up of columns. So here's, we'll get to one of Don's favorite things here as we're getting into some of this. If we want, that's simple enough when we have the just one column that we want to get out of there. But what do we do if we want to look at multiple columns? What we do is, instead of having one column name in there, we have multiple ones and we put them in a list. So we have the square brackets around that list, and then that's inside the square brackets that are around the name of the data frame. So in this case, if we want to take a look at these three columns, then we can look at, that was it in our DF? Did I do that? Yeah, DF. So that's actually, this is actually the code for it, if you want to copy that. So again, this is just displayed. This is not saved anywhere. But what this does is it says here, I'm going to give you a list of names of columns, location, age, and vehicle type. And let's pull those columns out, and then we can actually add that head on the end and look at the first 5 rows of that. That's called method chaining. We can add, in a chain, we can add methods on the end in some cases. And so we narrow things down. We could put it in one line of code. We could also take those 3 columns out, save them as a new data frame, and then look at the head of that data frame in a separate command. Now, if we need them as a separate data frame, then that's probably just fine. If we just want to see what's there, then this will work. That the double square brackets is another thing that takes you a little getting used to. But just remember, the inside square brackets are because it's a list. The outside is because that's how we access the columns in the data frame. So here is, I'll let you do this for just a couple of minutes. I've got just a couple of these scattered in some of this stuff. But look at, we've got that DF data frame, extract profit and location, save it in a new object called sub1_df, and then use print to inspect the last 8 rows. That's just 2 lines of code to do that. So let me give you a minute, 90 seconds, something like that, and then I'll type in here. See if anything we've talked about so far has made any sense. So with a lot of the code that you write, there's multiple ways of doing the same thing. There's really kind of just the one way. So if you came up with something different that works, then I'd be interested to hear about it. But were you able to come up with something like this or close to it? If you get an error in that first line of code, pretty much any error, the first thing I would do is go back and look at the column names and see if you mistyped them. One of the things that I do all the time is, and you might see that in some of the examples I do later, is if I'm dealing with the data, I make sure all the column names are in all lowercase letters, so I don't have to mess with capitalization. This is a data set that it got that's floating around out there that it used, so it could change them. But and then the inspect the last 8 rows of talking about using tail. And there's a couple ways you could do that one, but tail is so much easier. I know that this is also the kind of thing where when have you do it on your own, you might, a lot of times what I'll do is I'll ask about it, and the response is, it made perfect sense while you were doing it. And I know that's an issue with a lot of the coding, and sometimes it's like, oh yeah, it makes great sense, and then you start doing it yourself, maybe it doesn't fit in. It just takes experience, a little practice. So does anybody need any help with explaining that code, why it works or anything?
Yeah, I mean, you can feel free to explain it because I'm getting nowhere with it.
Okay. So if we're going to extract the profit and location columns from the DF data frame, then that's this part right here. So the data frame is called DF, and we use the square brackets. And if we just were going to use the profit column, we would just put profit in there in quotes. And remember, you can use single or double quotes. It doesn't matter. I usually use single quotes because you don't have to hold the shift key down. So it's just a little bit quicker. So somebody have something? So the outside square brackets are part of the DF, and then the inside square brackets are, we have 2 column names, so we have to put them in a list. So we have the 2 names with a comma in between them. That's our list of names. We could add a comma and another name if we wanted to get one of the other columns. And then when we get those 2 columns, we need to save them someplace. So that means we need something on the left side of the assignment operator. And we wanted to call it sub1_df here. You know, the name is whatever works best for you. And then the next line is, we're just looking at the tail of that data frame, and we put it in a print because it looks a little bit differently. If I just do the tail, it looks different. It actually, I think, looks a little better if you do it this way rather than print. Some of the things we do look better this way than with print, but some of them are set up where print works better. So you try whatever you like. Now remember, if we put 2 things on there where we're just looking at the variable name, so then if I just want the value that are in DF, it's going to overwrite what was there. So then it's a good idea to use that print statement, and that will still be there. So just a little extra about using the notebook, or do it in another cell. You say whatever works. Yes, the data frames and all this stuff has a learning curve, but it's one of those, once you get it, to me, it just kind of, everything opens up. It's like, it just makes sense and things kind of fall into place. Did anybody else have any issues or questions, or and did that work, or did we want to talk about that a little bit more?
Or? Well, after the break, Mike, I'm trying to link. And I may be getting ahead of myself, and slow me down if I am. I'm trying to link the conditional. What was it above? We looked at.
Yeah, we did the conditional on a series. We're going to do it on the data frame here in just a little bit.
There you go. Okay, cool.
Yeah.
All right, break time.
Okay. When are we back?
Let's take 10.
Okay.
So cell phone time. Start talking again at 10:18.
Okay.
And I'll pause recording.
I can't tell. Are we all back?
We are back and recording.
Okay. All right, I moved my window to the other monitor to make it a little bit easier here. So columns are real easy to select. When we get to rows, we use the LOC and the ILOC that we were using on the series. So Python uses zero-based indexing, which I mentioned before, and I'm sure you talked about previously. So rows start at 0 instead of 1. It's just one of those things that you have to get used to, and it's more or less universal. R, if you ever mess with that, does not use that because it was written by statisticians for statisticians and not computer scientists. So it starts at 1, but everything else runs at with 0. So we're going to use some of that same stuff we were doing with the series in order to get some separate rows out. Now, again, I will add that you're not going to use this nearly as often as the Boolean conditional type things, but it's good to know in case you do need to get some specific values out of the data. So if we want to select the first 90th and 178th row by label, then we use the name of the data frame and LOC, so .loc, because it's a method that's built into the data frame. And remember, with that, we use the square brackets. And we're going to get 3 different values, so we need to put them in a list, which means we have the double square brackets, because the middle square brackets are the list, and it's going to be the first, so that's going to be at index 0, the 90th, which is going to be at index 89, and the 178th, which is going to be at 177. So we'll see that it depends on exactly how you're describing the values that you want to get. You need to keep the zero-based index in mind if you have just the default values in there like we have here. We can also, and those are actually the label values, right? So we could also say, give me the value that's got the label value of 89, and we just give it 89. So if we're going to look by the index position and look at the first 90th and 178th, we do the same thing. We just use ILOC. Like I said, LOC and ILOC are a little confusing until you get a chance to work with them a little bit more. We can also do rows and columns at the same time. Whoops, I'm having a little trouble with my control. There we go. So we can use the LOC or ILOC depending on which is appropriate for what we're using in there. But we do rows first and then columns. So I just wanted to give you an example here. So we can use LOC because we're going to using here the actual names. If we use ILOC, we want to use the position numbers. We can use position numbers on columns, but it's really not a good practice because here age and profit, like I say, are self-documenting, so we don't have to explain a lot about what we're doing. If we just put in the number of the column, then that doesn't tell us what's going on. And it might seem like it doesn't make any difference as you're doing the code, but when you come back in 6 weeks or you get somebody else's code and they do stuff like that and you can't tell what's going on, it makes a difference. So we'll see with, if I run that cell, I get just the age and profit columns, and I get just the values that are at indexes 0, 14, 41, and 113. So we can pull specific values out. Like I say, if you've got a decent sized data set, I mean, even with 1,000 rows, it's really tough to know exactly what rows you want to get out. So we'll come to the Boolean condition again here in just a little bit. But that's pulling specific ones out. We can also do a range. And this is another thing that takes a little getting used to. And I think what we'll do is we're not going to spend too much time on this because I want to get to the Boolean and some of the other stuff this morning. But the big thing with the range is that we use that zero-based integer index value, but when we use the index integer values with ILOC, it's left inclusive and right exclusive, which means that you put the number of the first index position and it'll include that up to but not including the last one. So if you put 0 and 4, then it'll have 0, 1, 2, 3 will be included in your in the slice that you get. But if you use LOC and use the actual index values rather than the integer position, then it's right inclusive. So if it has the values, the first and last values, it'll include both of them. So like I say, yeah, it's confusing. Get a little experience with it. So we specify the beginning and the end with a colon in between, and then always keep this stuff in mind. Rows first, like I said, then columns. So let's just take a look at a couple of examples here. And I just have this DF head 10. Let's just see what the data looks like, those first 10 rows. So if we want right above that, select the 4th through 8th rows of DF and keep all the columns. So if we want to do that, we're going to look at DF, and then we are going to use the square bracket or ILOC because we're going to use the integer values here, and then the square brackets, and we want to get the 4th through 8th rows. So the 4th row starts at index value 3 and then colon, and so the 8th row, and this is where it takes some experience and like I say, it can be confusing. The 8th row is going to have index value 7. But if we put a 7 in there, it's not going to include that row. So we have to put in an 8. So it'll include everything from 3 up to 7, which is what we want. And then because we want to keep all the columns, what we do is we would put in a comma and the names of the columns. We just leave it blank and it'll include all 5 of those columns in the results. So let's see what it looks like. So there we've got, remember, the index of 3 is going to be in the 4th row of the original data, and the index of 7 is in the 8th row. So we got the 4th row to the 8th row. But it's better to really use the LOC and the actual indexes. Now in this case, in this data frame, they're the same values. So that's where it gets extra confusing, but we're going to switch back to that Pythons table here in just a second. So if we do the vehicle type and profit, and let's look at, and unfortunately let me do so it wraps around there. So rows 38 through 43, we're using LOC, so we're going to use the ones named 38 to 43 and the vehicle type and profit columns. So we can put those together. We'll again DF LOC because we're using the actual names, square brackets, and then let's use 38 to 44 because oh, I said through 43. So actually, when we use, go back to what I was talking about up here about the inclusive and exclusive. When we use LOC, it's right inclusive. So if we want to get 38 to 43, then we stop at 43, not 44. And then we want to get 2 column names. So we need to put them in a list. So we have square brackets again. And then we're going to get vehicle type, which is vehicle dash, capital T again, type. And then what's the, oh, profit. So there we can get 2 column names and the rows 38 to 43. So like I said, it takes some practice with that to get the hang of it, but we'll get to the Booleans here in just a minute. But again, that's probably how you're going to do things more than anything else is with Boolean conditions. But let's take a quick look at that Python's data frame that we did before. We've got the names as the row indexes, and then we've got the column names. And so if we want to take a slice of some of the rows, is that we can actually, it's like using LOC, but we don't even need to use it. If we want to look at all of the rows from Eric to Eric, that should just give us the Eric row because it's inclusive on both ends. If we want to look at Michael to John, then it's inclusive, so it should give us both of those rows. And it gives us that because they're in that order. There's no hierarchy to that value the way we always think of when we have numeric values. It's just based on the position in the data frame. It's the name of the row, and so it'll give us all the rows from Michael to row John. Like I said, don't be too frustrated if you don't quite get that. It does take some practice to get used to it. You don't use it that often, so I always have to go back and look stuff up to make sure that I'm using LOC and ILOC the right way. It just takes some experience. But again, the most common way that you're going to look at a data frame and pull out some values is going to be with those Boolean conditions. We do it the same way that we did it with the series. And what we're doing in the data frame, in the series, if we think of the series as a column of values that are in the data frame, we were looking at different values as we were moving down the series, if we think of it vertically. Well, if we put a bunch of those series together to make a data frame, those are just rows. So that's what we're doing, is we're going to select rows out of that data frame that meet a particular condition. So we looked at, in that series of grades, we looked at all the grades over at 145 or higher or below 90. Well, now instead of just getting the single values, we're looking for rows that meet a condition. So we might need to specify a particular condition in a column and bring back that whole row. So the general statement is basically the same. It's just we add a little bit more to it. So we said data frame conditional statement. So here we have, if we want to look in that Python's data frame, and let's look at, that's the name of the data frame, square brackets. So let's look at everything where the age is greater than 67. Well, we have to specify that column, and the way we specify that column is Python square brackets age, don't forget to capitalize. So we want to look at everything where the age column in Python's is greater than 67. And there's the two. The age, I threw the age, well, all that stuff is made up except it's based on real people. I don't know what their ages are, but they're all old guys now. But I just threw some values in there. But we get the two that are older than 67 in our data. So it brings back the whole row. So if you've ever done any kind of database stuff, then that is going to look an awful lot like a SQL statement. Let's bring back the data where it meets this criteria. So let's take a look at that Applewood data, and we're going to save it as cars, and we're just going to load it up here and take a look at the description. So again, if you have it in a subfolder, then make those changes in that statement and load the data. And we see we've got those numeric values there. So the same thing, let's create another data frame called sub_cars. We're going to subset here. And let's get the rows of cars where the age of the person that bought the car, and you can see it's in the column of the describe, is greater than 67. So again, it's in the cars data frame, and we're looking for the value of cars age is greater than 67. And then we're saving it in sub cars. And then I'm just going to print out what's in sub cars, so we'll take a look at it. So you see it extracted all the rows where the age was greater than 67. We could also, if we just wanted to look at, well, what about the rows where the location is this Olean or Olean or however they pronounce it there. Again, we're looking at the cars data frame, square brackets, and then what's the conditional? That's going to be where cars, the column location. Is going to be equal to Olean, Olean, whatever it is. But remember, this is the most common mistake. You need two equal signs. You probably talked about that. Remember, the equal sign is the assignment operator we've been using. When you want to test a condition, it's two equal signs together. And so now you can see in that result that it only brought the rows that are in that one location. We can also then, just one more example. You know, and the other thing is, you haven't done this in the notebook, we got a lot of results here. If you click on the left side, it'll roll it up and you can use a scroll bar. If you double click on the left side, it'll roll it up and keep it hidden. It just shows this ellipses here. If you click it again, you'll get back to that stuff. It's still there, it just rolls it up so it's out of the way. And if we want to look at the customers who made at least 3 previous purchases, then we can look at cars. And again, we're not saving these as data frames. This is just for display. And our condition is that cars, I think it's previous. Yeah. Previous. So we're looking at previous where it was at least 3. So we can look at greater than 2 or greater than or equal to 3, however you prefer to write it. And so we can see everybody that has bought 3 or more cars previously, 3 or 4 in this case. Does that maybe make a little bit more sense than some of the LOC, ILOC stuff we're talking about? Like I said, you can see intuitively this makes more sense, and it's more likely with your business experience, more likely the kind of thing that you're going to need to do is to go in and find out. It's the kind of stuff that we do with databases all the time. And we'll see lots of times where you'll go in and need certain data. Maybe you have, I always use, for some reason, I don't know, I seem to be obsessed with 1 gallon milk sales at Kroger. So I use that as examples all the time in class. But you might have all the data for every gallon of milk. Like I say, I hope there's a VP of dairy sales or something at Kroger. But if you're in that position, then you might have the sales of every gallon of milk that was sold everywhere in the United States yesterday. For the most part, you don't care about that. You might want to aggregate it, which is some of the data stuff that you can do, or you might just want to find out what milk sales happened in Arkansas. And so this would be the kind of thing that you can do. It's just a simple little query in one statement and pull the data out for Arkansas, and then let's do something with that. So it's very common that you might do something along these lines. There's a couple other things that I want to talk about really kind of quickly as we go through the last parts of this notebook. So this is a good time. Is everybody okay with, especially with doing this kind of an operation? The conditional
I have a question. I'm wondering, like, for those values that are strings, is there a way to find unique values? Because sometimes when I'm trying to search a data set, I need to see, like, what are the possible values I can sort by or that I can search.
Yeah, there is a unique, I don't remember the exact syntax of it because the last time I've been using it was in R, but there is something similar to that available in Python. One of the things that I find really helpful is that I might come in, and I'll just come down here and Python, or actually, I guess in this case, I might do pandas data frame unique. Panda unique values. Let's see what comes up. How to get unique values from a column. So there's lots of stuff. And here, the second one is the documentation. So that sometimes I go there first.
There's a group by.
But yeah, well, you can group by. Let's see what they're using here. How to get unique values. Yeah, just so there is a unique method that we can tack on the end of it. So let's let me insert below and say cars. Let's look at location. I thought that was it, but I know we were using something like that in R. So I know I typoed this. Yeah. So there you go. So you can get the unique values just by adding, again, one of those many methods that are in the data frame that you can access, part of the data frame. To me, the more I mess around with the data frames, the more impressed I am about the way that it was all set up and that people created pandas and included all this other stuff in it. Don't forget also about another thing that I like, just as helping me out, especially if I need to check on some things, but the columns attribute, it'll tell you the names of the columns that are there if you want to get them all. Now we're gonna, like I said, I'm gonna show you some data later that started out, it had 125 or 130 columns, so that gets a little bit busy, but I also will go into that, and you'll see with some of it, some of the names are really weird. So I'll go in here and copy and paste out of this output, just leave that output there and copy and paste, because I fat finger stuff all the time. I typo stuff all the time. So that way, when I've got some weird column names, I can put them in there easily. A lot of the stuff, once you play around with it for a little bit, you find what works best for you. So a couple other things, data frame modifications. And a lot of this, I left the code in here because I'll make it a little bit easier. This is a situation when you want to add rows to your data frame. If you're far into your analysis and you need to, there's combining stuff. I do a whole class on that now in my class. But you can use append and do some other things. So if you've got some data frames that are structured the same, you can also use a join like you can do in SQL, but that's a little bit beyond what we're talking about. If you just realize that, like here with this car data or the Python's data, I left one person off, I need to add a row. It's way easier to just go open the CSV file in Excel and put it in and then load it up. But you can add it. The first thing you have to do is create the new row that you want to create. It needs to be as a data frame, and then you can add that to the end of the row. And then this is just a warning that something's going to change in the future, but you'll see it didn't have any problems that added that to the end of it. Kind of a pain in the neck, but you can do it if you have to. I recommend just go and enter it into the new data and be on with it, unless it's a situation where you're needing to combine some data sets, and then there's other things like join and stuff like that. So, but if you want to add a column, and we actually add columns for a lot of different reasons, you need to have a series that you're going to add. So same thing here, as we create this series, we have these values and set the index values, because remember, those index values need to line up in order to add it to the series. And then this is what Python's did look like. And then if we add the new column, the way we do it is we say Python's, and then we tell it what do we want to call this new column. So we just referred to, I'm going to create shoe size. And let's put that new data series in that column. And then let's take a look at Pythons. And so now you see we've got a shoe size column there. There are lots of cases where we create columns by calculating a value. Maybe we have age there in years. Maybe we need it in months for some reason. So we can calculate it, create a new column with that. We can convert temperatures or currencies, or there's lots of stuff with dates where we might have a date where it's month, day, year. Maybe we need to separate each of those values out. We create new columns for that. So we create new columns a lot as we're analyzing data in data frames. But when we do it in those ways, it's kind of the same thing. We tell it the name of the column and then what do we want it to be. In fact, just as a quick example, we could create, doing stuff on the fly here off script usually comes to bite me in the backside, but I think we might be okay. So I'm just going to create age.
He's flying
here.
without a net.
I know. So
I'm always telling him that, Mike. Don't hold me accountable. I didn't practice this.
Yeah. So if we want to create age in months, we can say Pythons. It was just age, right? And that should give us, yeah. So, I mean, there we just created a calculated new column, just multiplied the original column by months and create a new column called age months. You know, we could do lots of stuff. Well, whatever it is that you need to do, a lot of different aggregations. And of course, we've got group by, and you can create that. You know, if you have any experience with databases, you'll talk about normalized databases where you want them to be as simple and as you can get, and you don't include things like age in months because you can always calculate it. But for analysis purposes, sometimes we need that column in our data because we can do things with it, either plotting stuff or doing calculations. So it becomes important to have that. So we can add columns as we need them. I do conversions and things that way too. If we we can drop columns, and we do that a lot of times as we're converting columns into different shapes and things, as we'll drop. So we'll say, in this case, Pythons dot drop, and then it's a function, so we're going to have the parentheses, not the square brackets, and then I want to drop the shoe size column. Now keep in mind, if I typo this and don't capitalize shoe, it's going to give me an error because it can't find it. But it's going to be an issue also if we don't include this other argument here, which is axis equals 1. Axis equals 0 is a row, axis equals 1 is a column. So we tell it axis equals 1 to make sure that it knows it's a column. Now, if you want to see what happens if you forget about that, we can do that with a comment. And you see we get an error. It says it's not found in axis because it's looking in axis 0. And so we say, oh, yeah, that's right. We have to say axis 1 because that's a column. And then it drops that, and you see it's not there. Wait a second, it is still there. This is actually a feature. So there's a fail-safe. When you say drop it, it shows you here, like this on this N60 cell, it shows you what it looks like, but it doesn't save it. It doesn't commit it to the underlying data frame. There's two things you can do. One is that you can save that as a new data frame, or you can use this parameter called in place equals true. I had a couple of experienced programmers in other languages in my class before this one guy kept saying, so we have to tell it that we're really serious about it this time. It's like, yeah, it's a fail safe. So it's the same command, and we just add this in place argument, and we tell it in place equals true. And then I think we have to display Pythons. And now it's gone. It really is a nice fail-safe. It's just like if you go delete a file, or you know, if you're gonna take a tab out of a worksheet and it says, are you sure you want to do this? It gives you that extra step to make sure that you want to do that. Now, one of the nice things, I was going to talk about this a little bit later, but one of the nice things about having all this stuff in Python and scripted in the notebook is that if I messed this up and deleted it and I didn't want to, and it's like, oh no, I needed shoe size, I just go back and rerun the code up to that creates it, and then just don't run that line again. So it's not like I overwrote my data in my Excel spreadsheet. I deleted a column and then accidentally saved it, and then it's like, oh, I've done all this work and now it's messed up. So the same thing is we could drop here, drop multiple columns at once. We put them in square brackets again as a list, and you'll see it's taken those columns out of there. But if we look at cars again, it's still going to have them, but we can come down here and add, run the in place equals true argument, and then it'll commit those to the underlying data frame. So dropping columns is pretty easy. Here at the end, I'm not really going to run anything, but I just wanted to include this because it's something that I talk about. We can save if you run this and then go to the folder where you have your code. You can also put a path in there to /data/cars_df. You're saving the data frame to a CSV file. So this is something that's very handy when you work on a bunch of data and then it either needs to go to somebody else or you're going to use it someplace else. What I try to do is to use a notebook for conditioning my data, and then I'm going to save it, and then I'm going to use another notebook if I'm going to do an analysis, if I'm going to use any machine learning or something else. But I try to clean it all up separately, and then I'm going to do the analysis something else. I don't know if I'm probably going to run out of time, but I was going to show you some of that I've done on another project. But it's a good idea to break things up into pieces. So, you know, you might get done doing all the cleaning and selecting all the columns you want and the rows you want and everything. We'll save it, and then let's open another notebook and work on it there, so that we don't have this huge notebook where we have a hard time to find anything. That will, if you open that, do this and open it in Excel, you'll see that it keeps the row numbers that it assigned. And if you don't want to keep those because they don't mean anything to you, which like in this case they wouldn't, add index equals false, and you can run that and look at that file and you'll see that it looks a little different.
Yeah, Mike, I was thinking that would be good practice, that previous point. That would be good practice because a lot of times you might use Python to automate the collection and wrangling, kind of like the ETL part. And then you want to open that clean, pristine CSV in Tableau or Data Studio or whatever your visualization product is. If you don't want to do your graphs in Python.
Right, and actually, I was one of the examples. The example I was going to show is I'm working on some data from a survey in China, and I did a bunch of the data cleaning, and then I turned the data file over to Dr. Downey in our department, who was doing some of the just basic analysis, and then it's going to come back to me to do the structural equation modeling. But this way I could clean the data and then give it to both of my co-authors, Jim Downey and Alex Chen, and say, here's our data set. Now you do whatever it is you want to do with it. And I can, I can recreate that using my script. And if this was data that I got regularly that was going to be done, then I could automate it a lot easier. Yeah, but they don't need to see, it's, like they say, you don't want to see how sausage is made. That's what I've done in my notebook to clean all the data, and I've told them about it, and it's all documented, but here's the data, so let's use this moving forward. So I'm able to save it as a CSV file easily. And in this case, when I brought it in, I think we just got rid of the survey IDs because it didn't matter anymore. So I wanted to save it without the row numbers and everything. So I used it index equals false. But just another, this is where I just kind of hammer on people of stick with the CSV files. If you have it in Excel, like an XLSX file, or heaven forbid in a Mac format or something, then just go back into that program and save it as CSV. The nice thing about CSV is I've given you the CSV files, and if any of you are using a Mac, you can open it with no problems, just like you can open the notebook files with no problems. They're basically universally usable. But there is Read Excel. There's a bunch of examples here on Read Excel and using database files. You can, the SQL Alchemy library gives you some functions. You can read out of MySQL and Access and all that kind of stuff. But so they're out there. But what I say is just go back into that file and save it as a CSV file. It's not that big a deal.
We used MariaDB on AWS to go through SQL, and guys, I have a notebook that connects to that very same database that we've been doing. I'll show you how a cursor works and how you can fetch data into a data frame using a SQL statement. So it works pretty cool. And then once it's in a data frame, then you can do all the stuff Mike's showing you, write it back out to CSV, goof around with it, whatever.
And that's kind of the other side of, like I say, stick to CSV files, but you may be in a situation where you don't have any choice and you have to access some of these other things. So then you can use those tools. But yeah, once you get it in a data frame, all this other stuff is the same. So let me get by. Like I said, we're going to spend a lot of time on that. I will just, this subset summary is really just a summary of what we did in that notebook. And I'm not going to run in. This stuff has all been run. The cells are all run. All the results are saved in there. So it's just a summary of what we did there. So if you want a reference, I would go back to this version of it, basically. And then if you need more exposition, then you can go to that one that we just talked about, that Pandas notebook. So that's why that's there. That's just, I found a couple of semesters ago that some students had some issues with some of it and they were having trouble going through it. So I did a summary notebook just to give them something as a help there. Let me close that so I don't have that sitting there. I'll close that one out too. So were you wanting to take another break here soon, or what were you wanting to do?
It's a little early. You want to get going? Yeah, because they've just seen Seaborn and how cool the graphing is, but we haven't done anything with it. Okay,
well, we'll do some in here, and I'll try to at least talk about the couple of other notebooks that I have. And I really would like to spend 5 or 10 minutes at the very end showing you that data cleansing on the China data to give you an idea of what I've done with some of this when we take it out of this kind of a environment. But Seaborn is another library. Like I say, if you've seen it, there's exploratory and explanatory plotting. For what we're talking about, I usually just focus on exploratory, where let's just see what's in the data and move on. When you get to explanatory, that's when you're going to have a meeting and you're going to explain to somebody what's in the data and the results, and it usually needs to look a little bit better. And you can spend a lot of time and get really into the nuts and bolts of creating publication quality output on plots. But that's marginally useful. We just want to have some ways to take a look at the data to make sure that we don't have any real surprises. I mentioned that I usually use a theme. This is if you're using another theme, it's from this Jupyter Themes library. And so when I run this, then it'll apply that theme to the plots and it shows up better. But you really have to show you for it to mean something.
Yeah, and we haven't installed it we haven't done like the pip install of that library. I don't think it runs.
Yeah,
it's built
so
into
this should not run. But if I go and change my theme, then you can see what it looks like. But I don't know that, unless I can maybe squeeze it in at the end, but try to get through some of this stuff. So I keep reminding everybody, if you remember what the exclamation equals is, that is the not equal to operator in Python. So just because you can create a plot doesn't mean that you need to. So, think a little bit before you start plotting. There's a lot of stuff, and the book that I use has a lot of plots in it, that a couple of them that I'd never heard of before. And a lot of times there's a plot that's real popular in a particular discipline, and they use it all the time, think it's the greatest thing ever. And people in other disciplines have never heard of it before, a lot of specialized stuff. So, but scatter plots, bar plots, histograms, and box plots are pretty common. So I tend to focus on that. There's Matplotlib is really kind of the basic tool, but Seaborn builds on top of that. And I keep going. I have been focusing on Seaborn. I'm almost ready to go back to just Matplotlib. So I go back and forth. There's some other tools too. But Seaborn does a pretty good job of covering the basics of what we do to get some exploratory plots. So take a look at it. Now this is another one. We have to import the library, and you probably already did this then. And the standard alias is SNS with Seaborn. So, and you have to spell as correctly. There we go. And Seaborn does take a few seconds to load up. But while it's loading, there are some formatting options. I'm going to show you a little bit of that, but that too. I think I could very easily do a very full semester long class on just some plotting stuff with Seaborn. There's so many things there. It's going to use the predefined color palettes. These are the names of the ones that are there. You can change that. One of the things that was really driven home, I think it was last spring, I had a student who was colorblind. And I already knew from talking about data visualization stuff in another class that actually, I think it's like 7 or 8% of the male population is colorblind, red-green colorblind. And there are a lot of other variations. And it's a very small percentage of females. But it's a good idea. That's why most visualization stuff doesn't default to red and green. It defaults now to orange and blue because there's a sizable amount of people that can't tell the difference between red and green. So there is a colorblind palette you see here on the list. And if you are going to be sharing your graphics, you might want to use that. But I'll show you a couple of those things. You can make lots of changes. There's a Seaborn link and everything. So here we're gonna change the palette to colorblind, but don't run it yet. We're gonna come back to that in a little bit and show you the difference. So the first thing, we're gonna run these examples using a data set that's built into the Seaborn library. A lot of the libraries have example data sets that are part of them, and you use this load data set method or function in that library in order to load it. And then if we see the info, we'll see that it is tips, as in tips for wait staff. So we have the total bill, the amount of the tip, the sex of the person paying the bill, whether they're smokers or not, the day, which is, you'll see there's categories there. We didn't see the category variables before, but day is Thursday, Friday, or Saturday. I think it's just the 3, maybe Sunday too. Time is either lunch or dinner, and then the size is the size of the party that's on the bill. So actually, it's probably a good idea to take a look at just the header so we can see what the first few rows look like. So you see total bill, $16.99, and so on. So smokers, just yes, no. It's a binary category. So there's some different ways we can look at things. One is we can look at one variable at a time. We like to use fancy terms, so we call that univariate data. So if we're looking at the categorical things, we're looking at count. So how many smokers and how many non-smokers. We can also look at some category. We can break some of our numeric variables into groups and do counts on that. So we'll look at some of the the common ways that we look at this data. So there's a lot of blank cells in here, but we're going to copy and paste a lot of times, so it's not going to be as bad as we think. Again, the standard way of doing it is to use this AX object name, variable name, to create our plot. So we're going to use that. But we call Seaborn, so SNS dot, and we're to do a bar chart, we use count plot. And they all have a very similar, all these methods have a very similar way of doing it, of doing the plot, as we have the Seaborn SNS dot and the name, the function that is the plot we're going to use. And then we specify the variables and then the options. So in this case, we have a variable name of X, and we're going to make it be the day. That's one of our columns. And then usually one of the last things that we do is we tell it what the name of the data frame is that this is based on, and this is going to be the tips data. So if I run that, you'll see I get this little box or bar chart. It is through Sunday, Thursday, Friday, Saturday, Sunday. So it shows us how many of our data points are in each of those days. And that tells us that for some reason we don't have a lot of Friday data. I don't know why that is, but that might be something we need to take into account later. Now, if that doesn't really work for you, change the X to a Y, and we can do horizontal bars. Again, one of the things that we talk about a lot in our data visualization classes is, like I said before, just because you can make a plot doesn't mean that you should. And if you're trying to just show how clever you are, you really usually show the opposite. So don't try to be clever. Try to do it in a way that the audience is, whoever's going to look at this is going to understand what it is that you're doing. So remember that set palette cell a little bit before. Let's go back and run that, and then we're going to rerun those two plots, and we'll see the difference. So go right there to the don't run this yet. I'm going to run that. You're not going to see any difference, but you see it's setting the palette to colorblind, changing the style to the ticks, and changing the scale a little bit. So come back down, and then let's rerun this one, and then compare it to the second. So you see if we can, let me shrink that down a little bit for now. So you see the color selection is different. We don't have the red in there anymore. We have the, we changed the scale a little bit, that 1.2. So you can fiddle around with the different settings, and you'll see if I run this next one, it has the same difference with the colors and stuff. You can really get into it, the different options. So I'll just leave this this style on here for the rest of what we're doing. If you want to return to the default, you can just run sns.set and with parentheses and nothing in it in a cell, and then it'll go back to the default values. But you know, if you change, you go back and rerun it, and instead of colorblind, you put in dark or one of the other palettes, it'll look a lot different. So that was just an easy little bar chart with some categorical data. When we're looking at continuous data and looking at a single variable, I think histograms are probably, histograms, and then when we get to two variables, scatter plots are probably the most often used plots. So it's a good idea to know. And what we do with a histogram is it's like we're creating a bar chart, but we're using continuous data, so we have to cut it into different chunks in order to make those bars. And we call that process binning. And more generally, we can call it discretizing, which is taking a continuous variable, making it discrete. But if you know binning, then you're good. We're creating bins to put those values in. And we can create all those ourselves. We could even do it in the data and make a new column or a new data frame that has it. But Seaborn has that built in. So we can actually create a quick histogram using the defaults. We have the AX equals SNS dot, and this is called dist plot, distribution plot, DIST PLOT, and all we have to do is tell it use the tips. Tips total bill. So we tell it which column, because we can only do one variable at a time here. And you see we get a little histogram. And one of the things, this gets into some of the underlying statistics and things, but the histogram you'll see always has no space between the bars, because that's to remind us that these are discrete ranges, but it's part of a continuous data distribution. So the bar chart, since it's counts of categories, they have spaces between the bars because they are discrete. So if you ever wonder about that. Now this, the display with using dist plot, has the histogram and this kernel density estimation. It's basically a smooth version of this histogram. There is a KDE option here. We can say set it to false. It'll take that out. We can use the bins option to tell it how many bins to create. Here it defaulted to 3, 4, 5, 6, like 12 or so. But we can tell it to do a smaller number. We can also set the overall title and then the labels of the X and Y to look something a little bit nicer. And so here we see what happens when we can change all that stuff. Now, like I said, you can go in and you can change all kinds of different values and create really fancy plots if that's what you want to do.
And Mike, can you just talk briefly about which line of code is actually displaying that thing? Because you're setting elements, attributes of that graph on 4 different lines of code, kind of, sort of. Which one draws it? When is it drawn?
It'll do it with this, just this creation of this one, and then change those other items on it. There's another. See, here we go too. I've had I get accountants sometimes in my graduate class, and accountants want everything to be neat and tidy all the time. And so a lot of them get really annoyed by this line that comes on this output here. So there is a way that you can do that. You can, by using matplotlib and using plt.show, it won't show that, but that's really all it does. It cleans that up. Now, I don't care about that, because like I said, we're looking at preliminary, let's look at the data. We might want to clean up our plot a little bit, but we're not too worried about actually showing this to the board of directors or anything. So I don't worry about that little thing that gets on there. So we can clean that up. And I'm also trying to keep it as simple as we can. But it's going to be that first line that creates that AX object that displays it, and then you changing the options on there.
All righty.
Oh, I was just about to go off script and I stopped myself. That might not have been good. So yeah, so we'll leave it at that. But like I said, there's nothing wrong. If you're checking out your data, there's nothing wrong with that. I mean, maybe you don't need the curve on there, but it's there, but you can see what else is there. You could go in here and you can change the, you can just change the number of bins and okay, you got it. I'm not going to worry about the KDE. I don't need to worry about it. You can see how it's distributed, both of them. So you get an idea. So you see most of the bills are in this range, and like I say up front, exploratory plotting, you're just wanting to see what the data looks like. You can also create a box and whiskers plot. You see this a lot with stock data and other stuff, something like this. So this too can be done with just with box plot in Seaborn, and we just specify what's going to be the variable we use. Now in this case, we use a Y. Well, you'll see we can use Y or X, but let's look at total bill, and then we say data equals tips. And you'll see here we specify Y. I think it'll do it. It does it horizontally if you specify X. Most people, though, when they see a box plot, they want to see it like this because that's what they're familiar with. And this, of course, includes things like the first and third quartile and the min and max, and these points here that are beyond this are might be outliers. You have to look at your data and check, but it gives you a visual representation that those could be outliers, but they're not necessarily by default. Now, if you want to look at a couple of variables together and the relationship between them, I think scatter plots are really kind of your go-to there. You see that a lot. So we can get a basic scatter plot just by using a function called scatter plot. So we can say sns.scatterplot. And then what we do is we tell it what is, a scatter plot is going to be on an XY because we've got two variables. So what is my X? It is the column called total bill. And what is my Y? That's going to be the tip column. So if we're looking at the total bill in relationship to the tip, what kind of a relationship should we see? It should be the bigger the bill, the bigger the tip, we would hope, especially if we're wait staff. And it should be kind of have a linear relationship to it. So we've got those, and then we tell it the data equals the tips data set. And we'll see we get a basic scatter plot. And we see it does kind of have a linear tendency that the bigger the bill, the bigger the tip. Although you see some people out here with pretty big bills that didn't leave much of a tip, and the other way, big tip on a small bill. But in general, it kind of goes that way. We can add some customization and stuff to this. And so this next cell has all of that stuff in it already. You see that first line is the same, and then add a title and a labels and stuff, and we get that garbage line there, but like I said, just ignore it. We can also put a regression line on there. You can do that in Excel and most other pieces of software, but it won't work in scatterplot. So, honestly, I don't use scatterplot a whole heck of a lot, but if you just want to see the scattered, you can do that. I use either LM plot or reg plot, REG plot. In this case, we're going to use LM plot. And if we use LM plot, it's actually, in fact, we can copy and paste that line, and we just change, like I said, they all have very similar syntax. So we can change the scatter part to LM, and the rest of it's the same. And so you see we get that fitted regression line, and then that blue zone around it is a confidence interval. We can do some customization and stuff there too. But another one that I find, and stop me if you need to, I find that I'm speeding up even more as we're getting later in the morning here. Did we need to take another break, by the way, Don?
Let's see. It's an hour since we came back. How much longer can you stay, Mike?
Well, I mean, I could stay longer, at least. Well, I kind of planned on noon. I could go beyond that a little bit if you wanted to.
Well, why don't we take a real short pause for the cause and come back in 5 then?
Okay.
That sound right? Just in
Yeah,
case.
that'll work.
So it's 11:16 cell phone time. 11:21, we'll hit it again.
Okay. So one of the things that I really like that like when I'm looking at a data set, if I want to use it for an assignment or something, is I look at the pair plots. And let me get this in because this does take a little bit of time to run, but this the TIPS data set is small enough that it's not too bad. But you'll see that what this does is it runs all the pairwise plots that you can do, and it just does the numeric one, so it's not going to do the categorical one. So you'll see the diagonal, it shows a histogram of that variable, total bill, in this case, tip here, and size. And then it shows scatter plots of the relationship. So this is tip and total bill. The X values are down here. So tip and total bill, this is the total bill versus tip, the one that we saw earlier, and then total bill versus size. So because size is a discrete variable, it looks a little different, but it kind of gives you a chance to see all of the relationships and see, is there anything interesting in there? So we know anecdotally that this should be linear, total bill and tip. So it would, if we didn't know that, it would look interesting. Since we know it, it's like, okay, it just confirms what we already knew. And then like here, the histogram shows that the size is typically 2 people. So, you know, we have a little bit of a better feel of what our data looks like. But I really like that. And you see, that took just a few seconds, but just by adding a couple more numeric columns, it takes longer because that's a lot of stuff. And if you get up to around 10 or 12 numeric columns, it can take several minutes for it to go. So the bigger it gets, the longer it takes to actually do that. But it's pretty handy. There are also ways to go in and customize what you see on the vertical and how it does other stuff. But, you know, like I said, that's getting out into the weeds that I don't think we need to worry about too much. But that's pretty helpful, especially with small data sets. If you want to go beyond 2 variables, you know, 2 variables, we can do an X and a Y. If we had a third, if we wanted to graph it, we'd go into 3 dimensions, which we can represent on the screen or on the page, but it's really hard to interpret. But we can add stuff like changing the color of the points. We can change the size of the points. We can change the symbol that we use to represent the points. We can do different categoricals on different plots that are all right next to each other. So I just want to show you some examples of some of that. And again, you can get way out into it if you really want to. So with the box plots, we showed that one on a, I just took all those options off. We can show multiple box plots, so we can have lunch and dinner by specifying here an X value. Remember that first box plot we did just had a Y, and by having an X, then we do the separate box plots. If we want to use different colors for different values of a categorical variable, we can actually use this hue argument. So I probably can type this as quickly as I can go back and copy this. So that count plot that we did early on, we can say X equals day, and we had data equals tips, but then we change it to, we add this hue option, which is our variable called sex here, and then data equals tips. And we'll see that now, instead of just having the 1 bar for the day, we've got separate bars by day for each sex value. We can also use, you'll see hue is used here. Let me go and wrap that around. Yeah. So by adding this CI equals false, it turns off that confidence interval light blue area we saw before. And by adding hue, then you'll see that we have male and female, the points are different colors. And then we have even the fitted lines are different colors. So we can actually get a lot more information on each one. And if we add hue to the pair plot, you'll see that one takes a little bit longer to run again. But now we've got a lot more information there too. So it actually applies that across all those graphs on the pair plot. I don't have anything in here. You can change the size of the points based on one of the, you know, like maybe you could make all the lunch ones twice the size of dinner, or you could make it change based on the size of the, but we don't use size very often because humans have a hard time discerning the different sizes, especially when you have different points, because it's really going by the area, and we have a hard time with that. So that's like the last thing, or if there's something that really makes sense, that would be the last thing that we would do. but we can use color and shape. And I wish I'd have left this one in there now. Let me get this last LM plot, this color, and I'm just going to edit that one. So I want the X and the Y, and I have data equals tips, and I'm using LM plot. So what I also want to do here is I'm going to, instead of the CI, I'm going to say fit_reg, which is fit the regression line, and I'm going to say false on that. So let's not include a regression line. And then hue is going to equal sex. And then let's add one more. We're going to add this option of markers. And so what we're doing with markers is we're telling it what little characters to use to mark the points. And since we have two, we have to have a list to tell it which ones. And there's some, if you go into the Seaborn package and you look at markers, there's some different options. What we're going to do is we're going to make the first one a little O. That's going to make it a circle. And then the second one, a little X, which is going to, unsurprisingly, make it a little X. And we can use plus signs, and there's different codes we can put for different shapes. There's a diamond and all kinds of stuff if you go to that help. And what did I mess up here? I'm missing here's another good example of finding an error. It says the error is data equals tips, but it's because I forgot a comma after the item before it. So now you see we've got male and female, different colors and different shapes. So we could change that. We could make the hue be smoker or something. So we can make lots of different changes to that. If you get really far into this, you'll see that Seaborn talks about facets and facet grids. And so you can do multiple plots together. The biggest thing to remember with that is you use this COL, which seems like it should be for color, but it means column. And it's where you wrap around to split a variable across columns to do multiple plots. You'll see it here in just a second. It'll make a little more sense. And col wrap feeds into that too. Scatter plot doesn't work, so we're going to use that LM plot. So back to the same one, like the original one that we did with sns.lm plot, x equals total bill, y equals tip. Total bill and tip, of course, are in quotes. We're going to set call equal to time, and then data equals tips. So I think the hardest thing to remember is that call is not color. You use hue for color. Call is column. So you see it splits based on the time variable. It splits them into their own plots. So you see lunch versus dinner. Now, Don had said that you guys looked at the Anscombe plots before, partly to see why it is that you would want to plot your data, because the Anscombe plots all have the same descriptive stats, but they look very different. This code right here will recreate that, but all in one plot. So get the data, create the data sets, and then plot them all in one. Let me make that a little smaller so they'll all show up in one screen. Well, it gets close. But so you can see all of those are in one plot, so you can have that all together if you want to. Make that a little bit bigger, back to where we were. So we can use hue and column together to do some stuff. Let's go back. I'm sorry if I'm rushing too much. I'm getting a little bit of that time is running out type panic. So since we don't meet again next week like my regular classes, I feel like I want to get through whatever I can.
Oh, but we can change that, Mike. You're welcome.
Little tip, column is time. Let's add to that one that I just copied. Let's add a hue equals smoker. Don't forget to put smoker in quotes because it's the name of a column. And then we have data tips. And so we'll see that that's now giving us the lunch and dinner on their own plots. Smoker yes and no have their own colors, and so they have their own regression lines and everything. And then now if we want to get even a little bit more fancy, you'd set markers to be the smaller dots. What else? Oh, the height and the aspect are more things. I'm setting the palette in case we were back on the default. And then this X jitter option. Let's run this and then you can see what it looks like. So we can do a lot of customizing here. And like I said, for the most part, for an exploratory plot, we don't care about it that much. But you can see here on this size, since size is discrete, see how these points are, they're not exactly lined up, they're off a little bit. That's what that X jitter does. When we have a lot of data points that fall on the same value, it adds a little randomness, just a little jitter to them, you know, just like shaking them up a little bit so they move, so you can tell that there are actual multiple points there. Like look at this size of 2 on Saturday, you would just have this green blob here and you couldn't really tell, but you can tell a little more that there's a lot of spots, a lot of points there. And of course we can say, you know, CI equals false to make it not show up. So here with row, column, and hue, we run this next one. And so now we have male at lunch, male at dinner, female at lunch, female at dinner. So we can add a lot of different levels to it. I'm also changing the height to make them fit on the screen a little bit better. So we change row and column, and we've got that little 2x2 for us. And you see those dots are so big. If we change the marker to the period, they would be smaller and it wouldn't just be a blob on the screen. And just in case you were wondering, if you wanted a scatter plot without the actual scatter and just wanted that line, that regression line, you can do it with LM plot. You just say scatter equals false and the confidence interval equals false, and you just get the regression line. So that seems kind of counterintuitive that you're going to do a scatter plot, but you're going to keep the scatter out of it. But that's how you can do it if you just want to see what that line looks like. In a lot of cases, if you want to change, you know, these are all labels, this time equals lunch and all, that's all added by default as you're adding these different values, these arguments. You can add different titles and things to LM plot. If you want to do that, it's usually easier to use the REG, the reg plot for regression plot, but you can do it and you can run that and it changes a bunch of different things. It's just another example. And then I have a reminder that just because you can make a plot doesn't mean you have to. And then here, if you want to see an example of what all those styles that we talked about at the beginning, here it needs Matplotlib to do this. So you can see what the different styles look like. And if you want it bigger, you can, I think the 2.3 is where you make the changes to do the sizes. It's been a while since I've worked with this code. But you see dark grid, it's dark in the back. You got light grid, just dark. There should be a grid in there somewhere. I can't really see it there. You have ticks here. You don't have any ticks here. So you can always try those different styles if you want to see what they look like, how they change things. So again, that was, you know, a total of about 45 minutes on stuff that I usually spend 2 or 3 days on. Here's that plt.show that displays everything and then doesn't show any of the other stuff. But it loops through the different styles and sees what they look like. anyways, just something for you to take a look at. A lot of examples there, and plotting, like I said, is important when you're first looking at your data, so you can know what you're actually looking at. I think let's talk about missing data for a little bit. The data types is that you can change if you get data that gets read in, like we were looking at location in that car data earlier was read in as characters. You can change it to categories with just a line, one line of code. You can change between categories and objects. Remember, object is a string in Pandas. You can change between those with a line of code, and it's no problem. If you get something that gets read in as a character, as an object, but it should be a number, then that's a little bit trickier, and that's actually most of what that notebook goes into. But that doesn't happen too often. Sometimes if we've got data that comes in, like I had in the Python's table, I had office number in there as COB 305 maybe. Sometimes we go in and we need to take the 305 part out, and then we might need to convert to a number. But most of the time, it's not too big of a deal. I can give Dawn the completed. A lot of the notebook is already there, but I can give them the completed notebook because I don't think we're gonna have time to really talk about that, and I'm going to have to kind of cruise through the missing data stuff here pretty quickly. This Taiwan cell survey raw is a subset of some actual survey data that we worked on, and kind of shows you some of this stuff. But the biggest thing with missing data is that just about every data set that you work with is going to have data missing in it for one reason or another. Pretty rare to get a data set, no matter who you get it from, where everything is perfectly fine. When you work with surveys, that's especially true. You can have this planned missingness, where you have a question where if you answer yes, then you answer this other question, but if you answer no, you don't answer it. So you know there's going to be some missing data. So the big thing with missing data is that you need to know what you're going to do with it going in. So there's a lot of different ways to take care of it when you're loading. You might know that the data that you're going to import is going to have some missing data. So let's make sure that Pandas is in memory. It should be, but always make sure. You might have some cells where there's truly no value. You might also have an NaN or none, or you might have another value like -999. I've done some stuff with people in psychology. If you're not aware, psychology does an amazing amount of statistic stuff, and a lot of the statistical developments that are really really advanced come out of psychology. I have no idea how that started, but they do a lot of stuff. And in fact, the first person I saw that used R when I first learned to use it at all 10 plus years ago was in psychology, because they do so much in stats.
And how did that make you feel, Mike?
Yeah, it makes me feel uncomfortable most of the time, quite frankly. But one of the things they do in psychology is they'll designate a missing value as -999. Now that works perfectly fine if that's not a valid value in your data. But so like if you use zeros, that's no good. If 0 is a valid, if you have how many days did you work last week and 0 is a valid response, then you can't use that, but you could use -999 or whatever works for you. I see it in psychology. I don't see it much other places. But we can do some stuff when we're reading data to take care of that. What I was doing here was something else that you can do reading data that can make it a little bit more interesting, especially if you're going to do it multiple ways, like we're here in these examples. And that is to set your file name or your path and file name to a variable. So I'm going to say office visits CSV. If you've got that file in another subfolder, then you'd want to include the path, the ./data/that. And then what we're going to do is, using the defaults, we're just going to read it, but so we don't have to keep doing that name over and over again. Hit the wrong one. is we're just going to say my file. So it just kind of cleans it up a little bit. And actually, it's office visits, isn't it? Yes, I left the S off. That's another common question that I get from students is it says my file's not found, but I know it's there and it's everything. Well, yeah, you typoed the name of it. So, which I just did. And let me fix that. And I also, after I read it, I want to print out DF and it shows you what's in there. So this file is, you know, something that I messed up. I added -999 here. It has NAN. It has none over here. So it has all these different values for missing data. And in fact, if I go, you'll see that one or two of those NANs are actually a completely blank space. If you see two commas together when you open it up like this, like here, line 7, 2 commas with nothing, that is a truly null missing value. These others have NA, -99, none. So you see NA is, I think, if I remember right, R, how R designates missing values. And that gets, by default, brought in as NAN. So some of them get handled the way you want, but not like none and -999. So we can specify, though, if I copy that, and I'm going to make some changes here, but we can tell it, hey, wait a minute, we've got none and -999. We want to make those be values that get brought in as missing values. So we say my file, and we use this NA values option. And with this, it's going to be square brackets. It's always going to be a list, even if it just has one value in it. And you'll see if we do it this way, now this -999 is now NAN, the way Pandas does it, but it didn't pick up none over here in cost. So we can do that just by changing that to include none. So in fact, I'll just go back here. Oops. And include the string none and rerun that. And now none was on line 4 in that last column. That's now represented as a missing value. And it's important that you get everything that is truly missing in there as a NAN value in Pandas as missing, so you can do something to all of them at the same time, hopefully. Otherwise, you've got to search for all these different values and everything. Now, you could also do this. It treated those default values as missing, the NA and all that, but you can change it to where you only do the missing, these as missing. I don't know why you would want to do that, but you can go in here and you just make one more change. There's a, here it is. There's an option there called keep _ default. It's not coming up on my autocomplete. So it's keep default, keep _ default _ NA, and we set it equal to false. And let me come back and roll that over to the next line. And if I run that, you'll see that this one that was truly null doesn't get an NAN, and this NA doesn't get it. So there are a lot of different ways that you can change the way that this missing lines are coming in, missing values. But the biggest thing is that you need to know, make sure that you at least handle the standard stuff. You need to know if you're going to have missing values, and you're going to have to do something with them. So if you have a really big data set, you might have to actually do some, it might take you 30 minutes of fiddling around to find out if you do have some values like -999 or something in there. If you just use those default values of NA, NAN, and a total truly missing, that'll catch most of what you might have. But be careful, if NA is a valid response that somebody typed in, then you don't want to treat that as missing. Of course, if you know that you're going to analyze, you're going to set up a survey or some data collection, then you want to make sure that nobody's going to put in NA as a valid response. So this kind of goes to the whole overall picture of collecting data too.
Well, Mike, not
Yeah.
to slow you down, but I think this is an important point as a researcher. You know, Python notwithstanding, but just as a researcher, when you have missing values, like say, I think, for example, a naturalist in the seaborne penguins data set, they don't get every measurement for whatever reason. They don't get every observation. So there's blanks in the data, and it's numerical data. It's like, you know, weight or bill length or whatever.
Yeah.
So when you've got numeric data and you have missing blank, you know, and there's blanks, a 0 is valid, and a 0 would be an outlier and throw off your descriptive statistics, you know. So what do you do philosophically as a researcher with missing data for either, you know, categorical, like what if they couldn't tell it was a male or a female, so it's blank, or they didn't get one of the measurements because the tranquilizer dart ran out or whatever. What do you do as a researcher with those blank values so that it doesn't throw off, it doesn't skew? Can you ignore them in your overall statistics of all your observations? What do you do?
Yeah, and like you're talking about penguins, one of your columns might be how many young that they have with them, and 0 is definitely a valid response, and it's different from a missing value where you couldn't tell. So there's lots of situations where you get to that, and that's something that you need to figure out philosophically before you're doing all this, or as certainly as soon as you possibly can.
But can you ignore, like if I ran the mean function on one of these numerical variable like cost?
If it has some missing, the short answer is if it has some missing values, I believe it'll give you an error, but you can tell it to ignore the missing values.
You can,
and
okay.
give you an answer anyway.
Yeah, good enough. I mean, because really, that's what you'd have to do. Okay, cool.
And then the same thing, and I think I'll probably switch over to it here pretty quickly. But to show you that Chinese data that I was cleaning, I cleaned up a bunch of stuff and replaced missing values, but there are some that are still missing, and it's because they're in variables that it doesn't matter, or we're going to use a technique on it that doesn't care about missing values. It's one of the things we get into. If you have this data and you're going to use a k nearest neighbors categorization method, k nearest neighbors does not like missing values. So you can't use any data that has missing values in it. If you're doing structural equation modeling on it, you can do usually work around the missing values. So some of it depends on the analytical tool that you're going to use down the road. You're usually better off cleaning up as much of it as you possibly can, as long as you do it without changing the underlying data. I was just looking ahead a second ago, and this Taiwan cell survey raw gives an idea of what the data set looks like. And I got a lot of empty cells here, so more typing than I had really intended, as it turns out, where we are here. But I can show you a little bit better, and I can give Don all the code to fill out the rest of this, or the completed notebook, because I'm okay with you having, this is data that we published, I don't know, 3 or 4 papers, or different combinations of people have published on it. So I'm not, and I've modified the data a little bit too, so don't have a problem with you guys having it. The other data I wanted to show you is an ongoing research project that's really not my data, and so I can't give it to you. Several of these cells, let's take a quick look. Several of the cells have the code in them already. But so here, let's take a quick look. Like I said, this is a subset of a bigger data set. This is just the cell data. There was also computer data. So you see this has 272 rows and 54 columns. The original data set, I took some of the other stuff that's with the survey. I think it was 135 columns. It's not a huge survey, so that's you do any kind of a survey that's going to take more than a couple of minutes, and you're going to have some columns. So you see 272 rows. Survey ID has 272 non-null string values. That's understandable, right? Now we could load this with survey ID as the index, and I think in a later example I do that. But one of the things you can look on it, you can see the next one, age, 257 non-null. If you do the math, 272 minus, that means 15 did not put their age in. So what are you going to do with that? There's a lot of different things we can do, and the example goes on with it. But if you look at some of these as we go down the list here, this @6F Facebook, this is, do they use their cell phone to do Facebook? Only 31 of them responded to that. Now, is that a problem? Maybe it is, maybe it isn't. But that's like Don was talking about, you got to know that going in. But you can see a lot of these, they have all valid, and then 5 comments is all it was. And I'll tell you, if you look at the data, it's all Chinese characters, so it doesn't do me any good. But only 5 of them out of 272 doesn't really do anybody any good. So it gives you an idea of what's going on. You can tell there's already missing values there just by looking at that that output. But let me do a couple of these and then move on, show you a couple other things as we wrap up. So if I want to take a look, that was read into DF2, and we can actually look at this is NA, and that it shows us that true false like we saw when we were looking for some other stuff. But we want to actually, what we want to see is DF2, and there is a count method that is built in, and we can it will show us all the values. But what we do is we put in axis equals 0, and that will give us a count of all the non-null values. I got to come down here a little bit. This is a long. Here, let's do this. Let me just comment that line out and just rerun that count. And that gives you the count of the non-null values, which is exactly what we saw in the info. But we can use that to get more information on that if we want to. We can also look at the frequency, like the question before about unique values. We can find on a categorical variable, we can get a count of the different unique values in the categorical variable. So this is one I told you about, it has some weird names, and it's because of the survey software. This was done in SurveyMonkey, and some of the values that were assigned to columns, that's why we get columns like BQ5A and @6A texting. If you want to clean those names up, it's easier to do it in Excel, but you can do it in Pandas. I usually go in and do some cleaning in Excel before I read it in. But we have this called value_counts. And what that'll do is it'll give us all of the different values there, except there's one issue here is it doesn't tell, it has all our 0, and it gives us in the descending order numbers. So you see the biggest number is 6, and there's 19 of those on down to 0, but it doesn't show any missing values. And maybe we want to know how many missing are in that column. So in that counts, we add this drop NA equals false, and that will include those, it'll tell us how many missing values. So then if we actually added those up, that should add up to the 272 that we know that we have overall rows. And just, I'm going to show you this in that other file. But like I said, and Don was talking about, we need to know when we go in what we're going to do with our missing values. So we can either ignore it. Usually that does not end well. We can drop those rows from the data set. That also is not a good position to be in. And there's I had an example where we were going to do that. And what happens with this data set is it drops all the rows, because remember, comments only had 5 valid responses, and then those rows that had comments were missing other values. So every row has a missing value in it, it drops them all. The other thing is, if you have a row that only has 1 missing value in it out of 54 columns or whatever, you're dropping the row. That means you're losing 53 valid data points. So you don't want to just drop the rows. Now, if you have 100,000 rows and you have 5 rows that have some missing values in them, then drop them and nobody cares. But so you've got to make a decision there on what you have to do, or what you want to do based on how it's going to affect your data. There's, if you want to fill in, and I'll give you this as a preview of what I'm going to show you here in just a minute. One of the ways is that we can create a fill value. We can do this directly in the next statement, but I like creating this intermediate variable. So this fill value, and it's a dictionary. And what we do is we tell it, I told you it's a key value pair. We tell it the column that we want it to go in and the value that we want. We could just say, well, let me show you this next line. I'm going to say df2. So the data frame number, let's call this method called fill NA. That's going to fill all the missing values, all the ones that are flagged as NaN. It's going to fill it with a value. If we just say value equals 60, what it'll do is it'll change all the missing values everywhere in the data frame to 60, and that might not be appropriate in some of those columns. So what we do instead is we make it be just that one column, and in this case, by using that dictionary, it will do the age column, and it'll have the missing ones will get changed to 60 in this case. And if, let's see, did we display the data set? No, it didn't just display the data set. If you look at it, the first rows are the ones that are missing the age. So this is all the replacement. Go into some other examples here. You could use mean, median, mode. You can use some really advanced statistical methods to replace those values. But however you do, you need to do something with it and know what you're going to do going in. So a lot of that gets into the philosophy that Don mentioned, and then statistical techniques. I mentioned before about dropping rows, and then at the end, there's some code about finding duplicate values and how to get rid of those. So let me go show you this. I've got 1201. Let me go show you this real example that I did recently, and I think give you a little more context on a couple of these things. Let me get rid of, and I'm going to have to go to a different directory. Actually, one of the things is I know you covered writing some functions. I've written some functions. Eventually, I might put this out in a library, but I wrote these functions, and I've got some other stuff to put in here to locate nulls in some in my data in some ways that I couldn't find anything else that did it. So I created these, and I've been kind of fiddling around with them. So you'll see the effects of some of those here in just a second. But this is the notebook that I use to clean this data. This is survey data from this Chinese data. So I'm importing pandas and then my own function. Here's how you change the display options so that you don't get those ellipses where it just shows some rows and some columns and then shows ellipses in the middle. This will show everything I need to show here. I read the data, looked at describe and stuff, which I already know, so I haven't run that lately. This is one of the functions that I wrote. This tells me how many nulls there are total, how many rows, columns, and nulls. So it's only 1.3-ish% of the total values, but we'll see here that it's really prevalent in some of them. If you ever do survey data, you will find there are a lot of people, and often I am guilty of this if I'm taking a survey, that start taking it and then they say, to heck with this, I'm not finishing it, and they leave. So you wind up with some values and then the rest of the row is null. That happened here. You always expect it to happen. I've got a couple other things here that versions of calling this stuff up. But so this is one of the functions that I wrote where I run this locate null on, and I want to see the top 10 rows with null values. So I have a row here with 49 null values in it. And this is out of, let's see, I had up here, 91 columns. So more than half are null. And if we go out and take a look at that top row, you'll see that we get to a point, and now it's just NaN, NaN, and then the second and third are the same, and on down. So these last ones here from V99 on are basically demographic variables. So you see a lot of the data that we were really interested in, they didn't bother to fill out. It's like, that's fine. I mean, you know, that's up to you. You can see some of these others, they're kind of scattered around a little bit. But by looking at those, I was able to look and see that these first ones, for the most part, didn't fill out the stuff that we wanted them to fill out. So I went in and said, drop. Here's the drop. And I said, here's the list of the rows that I want to drop, because I've got those in my output. So it's easy to just use the numbers right here. And then dropped it. And then, so it went from 428 rows, 91 columns, to 423 rows. Then I had written another, some more functionality down here that I'll check in a minute. But I know from the way that we, you know, the philosophy that Don was talking about, that these variables are measuring some constructs that we're really interested in. But I know that they should be, if it's missing, it should be replaced by 1, because our scale goes from 1 equals never to, I forget what the top value is. I think it's 7, but I don't remember what it corresponds to. It's the most, they use it the most. So I was able to fill it. So in that last example I did in the other notebook, I had this fill value dictionary. Well, here's a much bigger version that has all those fields in it, and then I want them all to equal 1. Here's another case where doing this way in the notebook is better than Excel, because if I send this now to my researchers, my co-authors, and they say, oh, you know what? Actually, Act 1 through 6 or 7 or 8, yeah, Act 1 through 8, we had that reverse coded, and so the default shouldn't be 1, it should be 7 if it's missing. I can go in and change those to 7 and rerun the code, and I've got the data. If you've already fixed it in Excel, you've got to go back and resort and do a lot of different work on it. So this replaces nulls in all these different columns, drops these 3 columns as unneeded down here, dropped these rows, and I added comments to say why. So we had no demographic data, so let's just drop it. It's, you know, 1 row is not a big deal. Replaced for the same reason the 1 value, and then ran that locate nulls function again. And now my rows with the most nulls have 3 nulls in them, and 2 and 1. And then if I look at, I also wrote a function that locates the nulls by column. So it says, like here, so row 118 has a null in PU8 and PT7. So those are nulls in 2 different constructs. The techniques we're going to use, we can probably just leave those alone. And then another little thing is to actually print those column nulls. And then now I can look at the total nulls again. You see I got it down to 43 out of over 37,000. And the 43 are either in demographic variables where we can just say that they didn't answer, or they're in a construct where we can deal with it. And then I save this to CSV and I send it off to my co-authors, and then they can work on it. And I did actually keep the index labels so I could map it back to the original data if I needed to. And that is something that I could use that if that was data that I got regularly that I needed to check, I could do that. Of course, the survey data is going to have some peculiarities that a standard data flow from from company systems is going to have a lot more structure that's not going to vary very much. So you can automate that stuff a lot easier, and it saves a lot of time over going through Excel files over and over and over and over again. Let the code go through it. They used to say with the phone book, let your fingers do the walking. You can let your Python code do the walking through the data here. Does that date me too much, Don?
Let your fingers do the walking.
Most of my students are a phone book. What's a phone book?
Could be all that white chin hair ages you as much as the old metaphors.
Right.
But what do I know? I'm just a jamoke, So Mike, thanks. We will build on this, guys. This was some good examples. Mike's going to email me the completed notebooks so that you'll have those code snippets to use as examples. But I'm kind of comparing and contrasting, Mike, as we go through the course, that there's more than one way to skin a cat. There's more than one way to get an answer. A lot of times when you're in Python and you used SQL to pull a CSV file to work with in Python, you wish you could go back to SQL and do it different. So there's so many different stages and so many different ways to solve problems and to figure out what's going on with the data, that we're just kind of looking at all of these tools, and then it'll be up to these folks in their jobs and the analytical processes where they work to figure out how they do it there, what the best practices are, and what the support is.
Yeah, and of course, like with that Chinese data, I did some upfront stuff with the first original data because it had some issues, and then saved that. But once I read it into Python, I did not save back over that original file. I save it in another file because I can always go back. And like I said, if Dr. Chen comes back to me and says that this is, we got this backwards or something, I can have him a new data set in like 2 minutes, because all I have to do is go back and rerun it and say, here it is. All the cleaning gets replicated exactly the way that I did it, and I can make the changes to whatever needs to change, and there it is.
Sure. Even in Excel, I don't overwrite a raw data set.
Yeah.
I'll duplicate that worksheet and monkey with it so that I always can go back to,
right,
to the raw data. So no, cool, guys. I mean, any questions for Dr. Ellis before we let him go?
Yeah, that's what I was going to say. If there's any, I know especially I started speeding up even more at the end, but
if you've got exercises, pandas, on the beginner side of things, pandas, homework questions, kind of like I've been using the Python workbook, which has a whole lot of just generic Python, generic Python, brain teasers. If you've got anything that you'd like to hand out for pandas, assignments, I would certainly get them to the group for them to practice on.
And with my classes, I normally have some stuff, that we stop during class, like we did, once or twice, and work on some stuff and get it worked out that I kind of took out for the, because of time. So I've got some stuff I can give you.
Sure. Anything you can share, I'll get to the group and they'll use it as appropriate for their work setting. And anybody, questions or comments?
Yeah, and I'm going to be spending more time with Python here the rest of June because, like I said, my data mining class is switching to Python starting next spring. We're trying to do it. So I do Python now at the undergrad and grad level. We moved it to the fall, and then we're going to do data mining in Python in the spring. And so give a little continuity for students and give them a little more depth of experience. And so there's not an off-the-shelf Python data mining book that exactly matches up with what I'm doing. So I'm working with that. But the more time I spend with Python, the more I like it. And so I find that I spend a lot of time digging around with it. So
well,
it's a big nerd thing, but
it is, but it's so fun to nerd out. Yesterday afternoon, I was working with the Google Maps API, and what you get back from that API is a crazy JSON object, which is a nested. I'll send you, if you've got a minute to look at it, you may know the easy way to deal with that. but that's off topic. I'll shoot you an email, Mike.
Yeah, I've worked on some web scraping stuff with Python too. We're going to do some research based on, we did some manual research based on some new sustainability metrics that Yahoo Finance publishes. We looked at oil and gas and collected it all manually, but we want to do the Fortune 500, and you basically need to scrape that. And so we're ready to go on that. We're going to be doing that pretty soon. That's pretty fun. There's so many things you can do. I did the pictures behind me and other in my office are pictures I took traveling, and I take pictures of food that I send back to my wife. And it's not that I'm messing with her. She wants that. So, because she can't travel. But I made a collage of all of them, and I ran some Python code that pulled the date and the location out and put it on a box on the picture and shrunk the pictures down. And I had to manually put the collage together, but it added all that stuff up. And so, you know, I made a list of all of my iTunes songs that still had copy protection on them. I mean, there's so many things that you can do with Python in so many different places that it's a good multi-use language.
There you go. Okay, guys. Well, I hope you're all still out there. I don't see any cameras on. And can everybody like turn on their camera and turn on their microphone and thank Dr. Ellis for this morning's presentation? Yay, we are here.
Thanks, Dr.
Yeah.
Thank you.
I swear. There's Damon. I see. I didn't want Mike to think that you were all mannequins and I was a fraud. All right. Appreciate it, guys.
Well, yeah, and it's always interesting with a group like this that, man, you guys have such diverse backgrounds. That's both frightening and cool at the same time. So, yeah, and feel free to if you need to have a question or something, you can email me. It's just mellis@uca.edu. So, and I think I put it in the notebooks. So, I'll be working on stuff here in June. You're not going to hear from me in July. I've got a big road trip planned, but for the rest of June, I'm definitely working on stuff. All
right, cool. Well, thanks again, Mike. I sure appreciate
Sure.
it. And guys, we will reconvene Thursday morning at 8:30. Any questions or concerns for me on just class and whatnot in general while you got me? Okay, shoot me an email if you need me. All right, thanks again, Mike.
Sure.
We'll see everybody Thursday.